Welcome to Prelim Preparation 2026. So this is going to be your preparation to this year's trial. Reason why I did this is that I went through the past papers for trial. They're a little bit trickier compared to the normal November paper. So I wanted you guys to be well equipped for your trial, as it contains a lot of marks in terms of like your final mark. So, and also the nice thing is that if you can master this and if you can do well in your trial exam, that means the fact that your November you have less stress. So that is why I decided to do this. So I have a recording schedule, right, or a release schedule on which when each paper is going to be released. So the preparation is going to start now, as you see in this video. So this is the release schedule, right? So it's within each date. So as you can see, the fact that we have June when each paper is going to be released, right? And also we have like July, right? As you can see, July is going to be like double releases because of like it's close to August, because then you have 1 month. And then we have lastly August, which is going to be this, completing the entire trial papers from last year. So this was very important for me to make sure the fact that by the time you guys write your trial exam, all the provinces are covered, right? Welcome to Gauteng paper 1. And as you know, the fact that the video also has the same thing but in PDF form. And with that is that you can only find that inside the membership. So what I'm going to do is that I'm going to show you a tutorial on how to join the membership and where to get the PDF. So with that said, let's do that. So first I'm going to show you guys on how to join the membership. Obviously, you're going to search my name, then you're going to click on my profile, then you're going to land here, right? Then you have two buttons. You have the subscribe button, right? And you also have the membership button, right? So the join button is where you join the membership. So when you click on it, right, you'll see the fact that this is going to be the membership, right? Then it tells you what you get: membership, only videos, early access, you get it, priorities, and all that, right? So now, do you see the fact that we already have exclusive content, right? So this content is strictly on the membership, right? So now when you say join membership, it's going to load, obviously. Then let me just say yes. Then it's going to load. Then when it loads, do you see the fact that now you're part of the membership, right? So when you scroll down, right, is that you're part of the membership, meaning you have access to all the members, right? So let me just go like this, right? So you can see the fact that you have everything that's related to members, meaning it's from the videos, right, to the most recent post, right? Then also now how to get the PDFs, right? So under members, you're going to see the videos. Then when you go through post, that's when you're going to see my post. You're going to see post of like public, and also when it's written to members only, you now can see it, right? As you see the fact that every time when I release a video, I do say the fact that there's a PDF. So this is the PDF for the NBT past paper, right? And also this is the PDF for the master series, right? Then this is like the normal posts, right? Then do you see the fact that this is the PDF for what? This is the PDF for paper 2, May, June. And also this is the PDF for what? For paper 1, right? Okay, so now let's go to one of the posts, right? We see the fact that this is the access. Now when you click on it, right, it's going to give you like Google Drive, because it's a Google Drive. So don't worry, it's public, right? So then when you scroll down, you'll see the fact that the PDF is within two versions, right? Is that you have the actual, it tells you that which PDF it is, right? Then you're gonna have the question paper first, right? Then after having the question paper, then you're gonna have the memo. The memo is exactly how the video is, but now it's in PDF format, right? So all of them are going to be like this, where you get what? You first get the question paper, right? Then underneath it is the memo. Hope that makes sense, right? So that is how you would get access to this PDF. So now we're going to do, so for X, so we're going to do the first question. So let's read the question. It says, given that f of x is equals to, then they give us f of x. Then they say the fact that solve f of x is equals to 0, meaning we're going to set this to be equals to 0, right? Then we're going to answer the question if x is an integer. So first, what we're going to do is that we're going to let this be equals to 0 and solve that first. Then we're going to move to answering these questions. Okay? So let's do that. So we're given that f of x, right, is equals to x squared minus 3, right? Then it's going to be 3x minus 1. Then it's going to be x plus 2, right? So first solve for what you call this when it's equals to 0, when f of x is equals to 0. So it's going to be 0 is equals to, then it's going to be x squared minus 3. Then there's going to be 3x minus 1. Then lastly, it's going to be x plus 2. Right? Then what we're going to do is that we're going to equate each bracket by 0. So let's do that. So we're solving for x, right? So it's going to be x squared minus 3 is equals to 0. Then O is going to be 3x. So it's going to be 3x minus 1 is equals to 0. Then O is going to be x plus 2 is equals to 0. So let's clean this up. So it's going to be x squared is equals to, take the 3 to the other side, so it's going to be positive 3. Then let's clean this up. So we're going to put square root on both sides. So it's going to be x squared is equals to the square root. Since this power is an even number, so here it's going to be plus or minus, right, 3. Hope that makes sense. The reason why we're doing plus or minus is because of this is an even number. So if this was to the power 4, it was going to be plus or minus. If this was to the power 6, since it's an even number, we're going to say plus or minus. Hope that makes sense. So this is going to be x because the square root and this 2 are going to cancel each other. Then here we're going to be left with plus or minus square root of 3, right? Then this is the same as having x is equals to negative square root of 3, or x is equals to what? To positive square root of 3, right? So we're done with that side. So now let's clean this one. So take the 1 to the other side. It's going to be 3x is equals to 1, right? Then it's going to be x is equals to what? Is equals to 1 over 3. Then this side is going to be x is equals to negative 2. Hope that makes sense, right? So we have our answer. So I'm going to highlight those answers. So let me just highlight them. So in green. So we know the fact that it's going to be this one. So it's going to be this one, this one, this one, and this one, right? Hope that makes sense. So now we can answer the first question. So now we done basically setting it equals to 0 and solving the x values. So let's answer the first question, right? It says 1.1, x is an integer. So from the ones that I've highlighted, which is negative square root of 3, positive square root of 3, 1 over 3, and 2, we need to give the ones that are integers, right? So first, let's understand what is an integer. So let me just understand what is an integer, right? An integer, it's basically numbers that are all positive, so counting numbers. So integers, counting numbers, right, that are all positive and including 0, then also negative. Like if you take a ruler, that is integers, right? So meaning we're not looking at halves and all that, if you can count it, right, but then include the negative numbers, right? So this are an integer. So let me just draw this line, just do this, right? And think about a ruler. When you think about an integer, think about a ruler, because a ruler has positive, no, it doesn't have negative side. So no, you can't think about a ruler. So this is going to be 0. So think about a number line. So 1, 2, 3, 4, right? And it continues always. Then to infinity, so this is to positive infinity. Then this is going to be negative 1, negative 2, negative 3, and negative 4 till negative infinity. So this is an integer. So this is an integer, right? So let's put it in a block in red. So meaning if this is an integer, we're looking for any number like 1, 2, 3 that is positive, 0, if we have 0 and we're looking for anything that is negative, right? So that's what we're looking for. Then now we see the fact that x equals to -2 is the only integer, right? Because this is a fraction and this is square root, right? So we're looking for x is equals to 2 is an integer. So we know the fact that x is equals to -2, right? So now 1.1.2 is a number that is what? A rational number. So a rational number, right? A rational number, right? A rational number is a number that can be written, written in a form a divided by b, right? Meaning in a fraction form, but very important, but a and b, so but a and b are an element of R. So an element of Z, meaning a and b needs to be integers, right? So meaning the number that's here, let me translate this. The number that's here and here needs to be the numbers that are only here. That's the only way that can be what? That can be a rational number, right? So hope that makes sense, right? So meaning obviously 1/2, like 1/2, since this is an integer and this is an integer, this is a rational number. 2/3, so example, maybe let's give examples, right? So e.g., right? So 1/2, right? 5/2. Also, any integer, right, can be written as a rational number, meaning you can take -4, right, and divide it by 1. So you can rewrite it as a rational number. Hope that makes sense, right? So that is the example. So let's put this inside a block. Right? Then let's go back, right? So we see the fact that here, this is not a rational number. So this is not a rational number, right? Do you see? This is not in a form of an integer because of any number. So meaning rational numbers includes what? Includes all integers plus fractions. Hope that makes sense, right? So we see the fact that this is not an integer, so it doesn't fit under rational. This is not, but these two are rationals, right? So we know the fact that our answer is going to be x, let's go back, x is equals to 1/3, right? Or x is equals to -2. Hope that makes sense, huh? So now 1.1.3, it says x needs to be real numbers. So real numbers is every number. So real number is every number. So real numbers. So let me just here maybe say I want to add something before we go up. I want to add something. So let's just move this so that this makes sense, right? A star, integers are included. Yes. So let's go take this up. Yes. So with real numbers is all numbers. So meaning is we're looking at rational, right? Meaning is this form, right? We're looking at integers, right, which is this form, and also irrational. So every number, right, besides, so it's every number besides undefined numbers. So any number, if you're getting decimals, every number is a real number, right? So every number is a real number besides the ones that are undefined. So the easiest way is every number, every number besides undefined. So undefined, right? So every number besides undefined, meaning e.g. 1, right? So 0.35 square root of 3 square root of 5, any number, and also maybe like 1/5, right? So every number. So let's put it down inside this block. And also there's a video where I talk about this, so I think I'll link a video so that you can understand the concept of integers, real numbers, whole numbers, and everything. I'll link the video. Né? So now if we go up, what is going to be our solution? Our solution for this one is all of them, because all of them are real numbers, right? So our answer here is going to be what? It's going to be x is equals to, I'm going to just say plus or minus square root of 3, right? Which represents this one, which is the same as this. That's why I just wrote it as plus or minus. Then it's going to be where x is equals to 1/3. And also lastly, it's going to be when x is equals to -2. So that's how you would answer question 1.1. So now we're going to do 1.2. So it says, so for x, then they gave us this. Then very important, they gave us an equation, right? But very important, they said to correct 2 decimal places, meaning we're using the quadratic formula, right? So we need to use the quadratic formula. But before even using the quadratic formula, is that let's clean this up, meaning getting rid of this negative, right? So let's get rid of this negative. So it's going to be -15 x squared minus 9x plus 4 is equals to 0. Pull out the negative, so it's going to be negative. So when you pull out the negative, everything that was negative becomes positive, and everything that was positive becomes negative. So this is going to be 15x squared, right? This is going to be plus 9x minus 4, right, is equals to 0, right? So since this side is equals to 0, I can just get rid of this negative, just drop it. Since very important, if it was equals to a number, we can't do what I'm just doing. Since it's equals to 0, I can just drop this negative. So it's going to be -15x squared plus 9x minus 4 is equals to 0, right? So now write the quadratic formula. So when you write the quadratic formula, we know the vector is x is equals to -x squared, negative b plus or minus square root of b squared minus 4ac, right? And this whole thing, right, is divided by what? Is divided by 2a. So what do we need? We need a, b, and c. This is your a, this is your b, and this is your c. Maybe let me just write it, right? So we know the vector, this is a, this is b, and this is c. So meaning our a is equals to 15, our b is equals to 9, and lastly our c is equals to -4, right? So now we're going to substitute, right? So when we substitute, let me just go up, right? So when we substitute, it's going to be what? It's going to be x. So it's going to be, let me just substitute here. So it's going to be x is equals to what? Is equals to minus, open bracket, 9 plus or minus, then it's going to be the square root. Hate this. There isn't space. So I think I need to do it here. Right, so when we substitute, it's going to be x is equals to, remember it's b, so it's going to be 9, right? Because b is 9, right? Then it's going to be plus or minus, so this is minus. Then since it's b squared, so it's going to be 9 squared, right? So it's going to be 9 squared minus 4, 15. Then this is going to be -4. Then this whole thing, right, divided by 2. Then this is going to be 15, right? So this is going to be like this. Now let's clean that up, right? So we're going to clean up what the denominator inside the square root. So this one is going to be -9. So it's going to be x is equals to -9 plus or minus square root. Then here's going to be 81 minus this whole thing. We're going to clean this up. Put that into the calculator. You find the fact that you're going to have plus what? Plus 240. Right? So that's going to be the square root. So this whole thing is going to be divided by what? 2 multiplied by 15 is going to give me 30. Clean up the square root, so it's going to be the same as, it's going to be the same as x is equals to negative 9 plus or minus inside the square root. It's going to be what? 321, right? And this whole thing is going to be divided by 30. So this is the same as x is equals to what? To negative 9. Since this plus or minus, my option is plus and negative, right? So it's going to be, the first option is going to be plus square root of what? Of 321 divided by 30. Or then the positive one, so it's going to be negative 9 x, sorry. So it's going to be x is equals to negative 9 minus square root of 321, and this whole thing is going to be divided by 30. So punching this into the calculator, you're going to find that x is going to be equals to what? It's going to be equals to 0, 0.30. Remember, it's two decimal places, right? So then the other one is going to be, for this one, is going to be x is equals to what? X is going to be equals to negative 0, 90, right? So that's going to be your two answers for this question. So now we're going to solve 1.2.2, which is the inequality. So we're going to use this table, right, to solve it. So the first thing first is that we need to write this in this form so that you can know which one to pick, right? So let's do that. So first thing first is that we need to write it in the form of ax squared, right, plus bx plus c, right? So let's do that. So we know the fact that we have 3x, right, minus 2 all squared, right, is greater than, so it's greater than and equals to 3x, right? So we need to sort that out. So when we sort it out, we see the fact that this side we're going to expand it. So when we expand it, we're going to have 9x squared, right, minus 12x, right, plus 4, right, is greater than and equals to 3x. Take it to the other side so that it can be 0. So it's going to be 9x squared minus 12x, right? It's going to be plus 4 minus 3x is greater than and equals to 0, right? Clean it up because there's like terms. So we see the fact that this and this are like terms, right? So we're going to have what? We're going to have 9x squared, and this is going to give me minus 15x plus 4 is greater than or equals to 0, right? So now we have it like this, right? So since it's in this form and it's positive, let's pick, and our a is positive, let's pick which one looks like this one, right? We see from our option is that it's eating the inequality. The inequality is eating the equation, right? And the zero, it's not eating the 0 sign, right? And it's equals to. So we see that our option is this one, right? So let's highlight our option. So we see the fact that, let me just increase. Okay, cool, wait. We see that our option is this one. So take red. I want this. So we see that our option looks exactly like this one. You see? That looks like that one, right? So meaning our answer is going to be what? Our answer is going to be what? So if it looks like this one, is that our answer? It's going to be x is an element, right, between negative infinity till x1, right, or from x2 till positive infinity, right? So now we need to solve for x1 and x2. To solve for x1 and x2 is that we need to basically solve for x here, right? So we're going to basically equating 0. So you're going to say solving CV, which in our case is x1 and x2, right? Hope that makes sense. Solving that, right, is that we're going to equate this by 0. So it's going to be 9x squared minus 15x plus 4 is equals to 0, right? So when we factorize that, right, when we factorize that, we're going to see the fact that we're going to have what? We're going to have 3x, right, minus 1, and we're going to have 3x, right, minus 4 is equals to 0, right? So we know the fact that this is going to be 3x minus 1 is equals to 0, or it's going to be 3x. So it's going to be 3x minus 4 is equals to 0, right? So it's going to be what? It's going to be 3x is equals to positive 1. Therefore, x is equals to 1 over 3, right? Then here it's going to be 3x is equals to positive 4. Therefore, x is equals to 4 over 3, right? Then between the two, you need to pick what's x1 and x2, right? x1 is the smallest one and x2 is the biggest one. What's the smallest number between the two, right? We see the fact that x1, right? Therefore, this one is going to be x1 because 1 over 3 is the smallest, right? Then therefore, this is going to be x2 because that's the biggest. So x1 is the smallest one and x2 is the biggest. Hope that makes sense, right? So now with that, now let's take our answer. Remember the fact that our answer needs to be in this form. Let's put it in red. This is how our answer needs to look, right? So we know the fact that our answer needs to be that one. Duplicated. Okay, wait. Let me just, I want to just take it again, because I want to cut. Yes. From here, I want to substitute my x1 and x2, right? So we see the fact that x is going to be an element from negative infinity till 1 over 3, because that's x1, or, sorry, square bracket, or square bracket 4 over 3 till positive infinity. So that's how you would write the answer for this one. Hope that makes sense, Anna. So now we're solving for x for 1.2.3. So we have what? We have 5 to the power x is equals to 5, then open bracket 4 plus 5, then it's going to be 2 minus x, right? Then it's like this. So we need to solve for x around this, right? So the first thing that we need to do is that we need to clean up this, right? Meaning we need to expand it, right? Then just clean up this exponential, the fact that everything is in its individual terms, so we can see what we're dealing with, right? So let's do that. So first, let's distribute the 5. So it's going to be 5 to the power x is equals to, there's going to be 5 multiplied by 4 plus 5 multiplied by 5, 2 minus x, right? So let's clean this up. So it's going to be 5 to the power of 5, and this is going to be what? This is going to be 20 plus 5 multiplied by 5, 2 minus x, right? So now we're going to expand this, right? So this is the same as 5 to the power x is equals to 20 plus 5 multiplied by 5, right? And maybe I'm going to put it inside the bracket so that we know that we're dealing with this one. Then this is going to be 5 to the power 2, then multiplied by 5 to the power negative x, right? And this comes from what? This comes from a, right, to the power x plus y is the same as ax multiplied by ay. So let's put this inside a square. So this comes from this exponential law, right? So what I did is that I took this and did this. Normally what you get is this, then you do this. So I just reversed it. Hope that makes sense, right? So now with that said is that I don't want to deal with negative what? I don't want to deal with negative exponent. So I'm going to take it to the denominator. So it's going to be 5 to the power x. And the reason why is that I want the 5 to the power x, this one, to match with this. So to do that is that this needs to go to the denominator. So it's going to be 20 plus, this is going to be 5, right? Then now this is going to be 5 to the power 2. Then this is going to be 5 to the power x. Hope that makes sense, right? So now let's clean this up. So it's going to be 5 to the power x is equals to 20 plus, then this is going to be 5. Then this is the same as 25, right? And this whole thing is going to be 5 to the power x, right? Then this is going to be 5 to the power x is equals to what? 220 plus, when you say 20 multiplied by 25 multiplied by, when you say 5 multiplied by 25, you're going to get 125. So it's going to be 125, right? And this is going to be 5 to the power x, right? So very important, if you have a question in this form, very important, where 5 to the power x, right? It could be 5 to the power x, it could be a number, so it could be a number to the power x, and it's in the numerator and alone without any number, and another one is in the denominator, you always let k. Hope that makes sense. We always let k. So you'll see, you're gonna say now let k equals to, let k equals to 5 to the power x, right? So now we know the fact that now substitute wherever you see 5 to the power x, you substitute by k. So now it's going to be k is equals to 20 plus 125 divided by k, right? So now I want to get rid of this k, so I'm going to multiply throughout so that we have k everywhere, right? So it's going to be k, so multiply both sides by k. So what I mean is going to be k multiplied by k, then is equals to what you do into the left hand side, you do to the right hand side. So it's going to be k, then this is going to be 20 plus 125 divided by k, because I want to get rid of this k. Hope that makes sense, right? So we see the fact that the side is going to be k squared is equals to, distribute the k, so it's going to be 20k, right? Plus this is going to be 125k divided by k. We see the fact that the k's are going to cancel out here. So this is the same as k squared is equals to 20k plus 125, right? We see the fact that we have k squared and we have a number with k, so this can be what we can factorize it, but let's take this to the other side so that we have 0, so we can factorize it. So it's going to be 0, then this is going to be let's take everything to one side where there's, I don't want to deal with negative because I want my k squared to be positive. So let's take the numbers to the other side. This is the same as k squared minus 20k minus 125 is equals to 0. We can factorize that, right? So when we factorize that, right, we see the fact that k minus 25, right, and the side is going to be k plus 5 is equals to 0. Hope that makes sense, right? So now equate both bracket by 0. So we're going to have k minus 25 is equals to 0, or it's going to be k plus 5 is equals to 0, right? So it's going to be k is equals to 25, and here's going to be k is equals to negative 5. But remember that our k is what is the one that we're solving, 5 to the power x. So let's substitute. So this side is going to be 5 to the power x is equals to 25. And this one is going to be 5 to the power x is equals to negative 5. Very important keynote, right? If you're dealing with a number to the power something and the other side is negative, this is undefined. So we know the fact that by default this is not a solution, so we're going to be dealing with this one only, right? So now we know the fact that 5 to the power x, we know the fact that 25, we can write it in terms of what? We can write it in terms of 5, right? This is the same as 5 squared. Then what do we see? We see the fact that the base is the same. So we see that the base is the same. So we can drop the base, right? So therefore, we see the fact that x is equals to 2. And that's going to be your final answer for this question. So now we're going to do 1.3. It says solve for x and y. Then we given the fact that this one, right, log x 16 is equals to 4. And the other one is this one. So what I'm going to do is that I'm going to name them. So we know the fact that log x 16 is equals to 4, right? We're going to name it as equation 1, right? Then y plus square root of x plus 7 is equals to x plus 1. Then we're going to name that equation 2, right? So now taking equation 1, let's simplify equation 1, right? So let's simplify equation 1 so that we don't deal with roots, with logs, right? So taking 1. And the nice thing about equation 1 is that it doesn't have y, it's only x. So we can solve for x, right? So taking 1 and solving solving for x, right? So we have what? We have log x 16 is equals to 4, right? So what is this, right? If you change a log, we change it to exponents, right? And we already know exponents rule, right? So we know the fact that this is the base, right? So in exponential, we know the fact that this is the base. So we know the fact that this is going to be x, right? So it's the base, right? Then we know the fact that this is the number that is equals to, right? So we know the fact that this is going to be the number that's equals to. Then we know that this number is the power, right? So this is going to be 4, right? So we have what? We have 4, what you call this, x to the power 4 is equals to 16, right? So we know the fact that this, remember the fact that this is the base, this is the number that's on the other side, and this is the power. Maybe let me just emphasize, no, write it. So we know that this is the base, exponent, number on the other side, right? So now we know the fact that that's this. We can deal with this, so we can square root both sides, right? We can fourth root both sides, right? So this is the same as what? As fourth root of x to the power 4 is equals to the fourth root of 16, right? So now you're probably asking yourself the fact that why we're not saying plus or minus since the power is an even number. The reason why we're not doing that is because of this log, right? The log is always positive, so that's why we only take the positive one, right? Hope that makes sense. So therefore, x is going to be equals to 2, right? So now what we're going to do is that we're going to substitute, right? We're going to substitute x is equals to 2 into what? Into equation 2, right? So we know the fact that equation 2 is y plus, let's go up, y plus, then this is going to be the square root of x plus 7, right? Right, is equals to x plus 1, right? Yes. So now let's substitute. We know the fact that y plus square root, this is going to be 2 plus 7. So wherever we see x, we're going to put 2. And this is going to be 2 plus 1. So we know the fact that y is equals to the square root of, this is going to be 9, is equals to 3. So therefore y is equals to, y plus, this is going to be 3, is equals to 3. Take the 3 to the other side. Y is equals to 3 minus 3. Therefore, y is going to be equals to 0. So our x value is 2 and our y value is 0. Hope that makes sense. So now we're going to do 1.4. It says calculate the two numerical values of p so that this whole thing is perfect root, a perfect square. We need to understand what does it mean to be a perfect square, right? What does it mean? What does it mean to be a perfect square, right? So it means the fact that the determinant, which is the triangle, right, needs to be equals to 0. So that's what we're looking for, where we know the fact that the determinant, which is the triangle, is equals to what? The formula for that is negative b, right? Is negative b. So it's going to be, sorry, it's not even negative b. Ooh, big. So it's going to be the triangle is equals to b squared minus 4ac, right? So that is the formula. If you want to know this formula is what the triangle is basically. Let's go up. I want to show you it's from where. It's this thing. If you forget it, that is the triangle. Go to your formulation. This is your triangle, which is the determinant, right? Then now what that is equals to 0. That's what it means to be a perfect square. So let's put this here. Put in a square. Then this is this, right? So we're solving for this. which you'll see the factor is going to be in terms of P. So let's do this. So the first thing that we need to do is that we need to rewrite this in a form of ax squared, right? Ax squared plus bx plus c. So number one, right, we need to rewrite rewrite x squared plus p 2x plus 7, right, plus 8 in a form of a x squared plus b x plus c, which makes sense, so that we can substitute. So we're going to have our a, b, and c, right? So let's take that. So it's going to be a x squared plus, distribute the p, so it's going to be 2xp plus 7p plus 8, right? So for a, right, for a is the one that has x squared, so this is going to be your a. So this, let's do this. So let's do this, right? So this is going to be your a, which is 1, right? Then from here, right, we're looking for the one with what? The one. So this, we're looking for the one that's going to be your b, right? So the one that has x, right? So we see the vector. Let's rearrange this. So when we rearrange it, it's 4p. So we don't want the x. Basically, you don't even need to rearrange it. We don't want the x. So meaning here, right, the one without the x, so it's going to be 2p, is going to be our b, right? So b is equals to 2p, right? Then this whole thing here, right, the whole number without x is our c. So this is going to be equals to c, which is 7p plus 8. Just want to emphasize here, so that you don't get lost, is that our b is the one that doesn't have, like, we just take out the x, we ignore the x, everything else besides the x. Hope that makes sense. Here it's 1 because of there isn't any number in front of it. Hope that makes sense, right? So now let's solve our triangle, right? So we know the fact that our triangle, right, is equals to b squared minus 4ac, right? So now let's substitute, right? So when we substitute into our triangle, we're going to have the following. So we're going to substitute. It's going to be the triangle is equals to, our b is 2p, right? So it's 2p all squared minus, then 4a is 1, then c is what? Is 7p plus 8, right? So now let's clean this up, right? So when we clean this up, we know the fact that this triangle is going to be it's going to be 4p squared, right? Minus, clean this whole up, so distribute. So this is going to be 4 multiplied by 1 is going to be 4. Then this is going to be 7p plus 8, right? So now let's clean that. So it's going to be the triangle is going to be 4p squared minus, distribute the 4. So when you distribute the 4, this is going to be 4 multiplied by 7p, which is going to give you 28p. Then it's going to be negative 4, right, multiplied by positive 8, which is going to give you minus. So it's going to be minus 32, right? But remember the fact that we said the fact that perfect squared means what? It means the fact that the triangle is equals to 0. That means to be perfect square, right? And that's what we're looking for. This is going to be 0 is equals to 4p squared minus 28p, right? Then it's going to be minus 32, right? Then now basically what I'm going to do is that I'm going to divide everything by 4. So it's going to be 0 is equals to, because everything has a what you call this, a factor of 4. So it's going to be the same as 4p squared divided by 4 minus 28p divided by 4 minus 32 divided by 4. Let's clean that up. It's going to be 0 is equals to p squared, right? Then here's going to be 7p. Then this is going to be minus 8, right? So then we have that. So now let's factorize that. So we're going to have 0 is equals to what? It's equals to p minus 8. Then the side is going to be p plus 1, right? So now we know the fact that equate each bracket by 0. So it's going to be p minus 8 is equals to 0. Or it's going to be p plus 1 is equals to 0. So our p is going to be either equals to positive 8. Sorry, it's going to be positive 8. or P is going to be equals to -1, right? So that is going to be your two answers. P is going to be equals to 8 or P is equals to -1. So that what? So that this is what? This whole thing becomes a perfect square. Hope that makes sense, Anna. So now what we're going to do, we're going to do sequence and series, right? So we're going to do question 2. It says the following sequence, right, of a number forms a quadratic. So we know the fact that we're dealing with a quadratic. So let me just highlight that part. We know the fact that we're dealing with the quadratic number pattern, right? And they gave us the pattern, and here's the pattern, right? So now let's basically just take the number pattern and basically find the first difference and the second difference, right? Then we'll answer the first question. So we see the fact that our sequence, right, is -3, it's -2, it's -3, it's -6, it's -11, right? Then it continues. Then first we're going to find the first difference. So it's going to be what? It's going to be -11. So let me just do it on the side. I'll erase it so that you guys can see it. So we know the fact that it's going to be -11. So you always this number, then minus the one that's in front. So it's going to be -11. The reason why here I'm showing it is because if we're dealing with negative, it's -11 minus open bracket -6. Because this negative is going to basically affect it. So this is the equivalent to -11 plus 6. Because in negative and negative is going to give you positive. So when you put this, when you find the difference, we see the fact that this is going to be -5, right? So we're going to do the same thing. So we know the fact that this is -5, right? So now we're going to find this difference. Same thing, right? So same thing. I'm just I don't want to change colors, so it's going to be -6 minus -3, right? Then this is the same as -6 plus 3. So punch that into the calculator. Make sure the fact that you add the brackets. So this is going to give you -3, right? So here it's going to be -3. Then this one, right, which is going to be what? Which is going to be -3. So it's going to be -3 minus what? Minus -2, right? So punch that into the calculator. You're going to get your answers -1. Then lastly, we're going to have what? We're going to have -2 minus open bracket -3, right? So it's going to be -3. So that's going to give me what? That's going to give me that is going to give me a +1, right? So this is going to be -1 and this is going to be +1, right? So that is our first difference. Hope that makes sense. That's going to be our first difference. Then now finding the second difference, which is going to be this one, which is going to be the same thing that we did. So it's going to be -5, right, minus open bracket -3, right? So when you do that, we're going to find the fact that it's going to be -2. Then same thing here, right? So same thing here. It's going to be -3 minus open bracket -1. We're going to still get -2. And lastly, it's going to be -3 minus 1 and -1, which is going to give me -2, right? So this is your first difference, right? And this is going to be your second difference. Hope that makes sense, right? So now, with that said, is that we can answer the question, Nane? So answering the question, it says determine the first difference of the given sequence as a form of a sequence. So they want us to now consider this part as a sequence. So let me just take this, right? They want us to consider this as a sequence, right? So we're going to consider this as a sequence. So I'm going to just make it in a color. So let's make it blue. So they want us to take the first difference and consider that as a sequence, right? And we need to determine what? We need to determine the nth term, right, for the first difference. So basically what we're doing is that we're taking this, and that is our sequence. And we see the fact that this is what? We see the fact that this is an arithmetic, right? So with the arithmetic, we have a common factor, what you call a common difference, right? So that's what it is. So taking, so what I'm going to do is 2.1. So let's do this. Yeah, so 2.1. Right, I'm going to take this as our, basically, I'm going to just copy and paste this. I have to copy, then paste. So I'm just going to paste it here because I want to write notes, right? the first difference, right? The first difference, right, is a linear number pattern, right, which is an arithmetic, a linear number pattern. And what do we know? We're looking for Tn, right? Since we know the fact that it's a linear number pattern, we know the fact that Tn is equals to a plus open bracket n minus 1 then d, right? So here we need a and we need d. We see that a, right? We see that a, so let me just go back. We see that a is equals to what? It's equals to the first term here, right, of the first difference. So we see that a is equals to 1. Then we see that d is the common factor, right, the common difference, which is this -2, right? So we see the fact that that is going to be -2, right? So now substituting, we know the fact that Tn, so Tn is going to be equals to what? It's going to be equals to 1 plus open bracket, it's going to be n minus 1, then it's going to be d, which is going to be -2. So now what we're going to do is that we're going to distribute the 2 here and here, right? So when we say -2, right, multiply by what? Multiply by n. So it's going to be 1 minus -2n. Then when we say -2, multiply by 2 is going to be plus 2, right? Then now let's simplify it. We see the fact that we have 1 and 2. So this is going to be the same as -2n, right, plus 3, right? So therefore, we see that Tn is basically equals to -2n plus 3, right? So that's how you would answer this question. So now we're going to do 2.2. It says calculate the first difference between the 35th term and the 36th of the quadratic. So we know the fact that our sequencing is like this, right? We have the quadratic, right? We have the first difference, then we have the second difference. So they want us to calculate from the quadratic, the 35th and 36th term. So the 36th term, meaning we need to calculate the first difference, right? From the first difference. So we're going to use the Tn because it has the first difference, right? So I want to explain something. First, let's understand is that T35, right, and T36 is from the quadratic because they said that, right? So from the quadratic, right? So from the quadratic. So what they want is that they want this, right? The first difference. So the first difference, let me just zoom it in. So they want the first difference, right? So the first difference from this 2, right? But we know the fact that the first difference, we already have Tn, which is equals to what? Which is equals to -2, right? N plus 3. Hope that makes sense, right? So we can use that. Then now the question is, what n are we going to use, right? What n are we going to use? We always use the n that's in front. So our n here, right, is going to be equals to 35. And just to prove the fact that this is correct, right, just to prove that this logic is correct, I'm going to take one where we already know what is the first difference. So let's go up. I'm going to take one where we already know what is the first difference, right? So I'm going to cut this. So I'm going to cut this, right? Copy, cut, right? So I'm going to go here, right? So we know the fact that this is, let's say the fact that they gave us what? Let's say the fact that they gave us T2, right, and T3, right? Let's say they gave us T2, not they didn't give us. They said the fact that find what? Calculate the first difference between T2 and T3, which is the one in red, right? So meaning they want you to calculate this one, right? So what I said is that to calculate this one from the first difference, remember the fact that we already have Tn here, it's equals to -2, right? -2n plus 3, right? We have that formula. So our goal is to get this. Let's say we don't know what it is. Our goal is to get this, and they gave us this formula. I said the fact that we know the fact that to do that, and let me just do this triangle. Okay, I want to emphasize it more. So let's put a triangle here. Yes, right? So our goal is to calculate that, right? So let me just change color. maybe red, green, right? So our goal is to calculate this value -1, right? So I'm saying the fact that to find the n here, right, is the same n it's here. So let's check whether that's true. If we say in the fact that the n is always the number that's before, which is this one, right, is that if here n is equals to what? Is equals to 2, because that's the number that's in front, right? We need to get what? Our answer needs to be -1. Let's test it out. So if we're looking for T2 is equals to what? Is equals to -2, then we're going to say 2 plus 3. Remember, the n that I'm talking about is the small number. Hope that makes sense, right? So now let's clean this up. We know the fact that T2 is going to be equals to what? It's equals to -4 plus 3, which T2 is going to be equals to -1. Do you see the fact that -1 is exactly here? Hope that makes sense, right? Hope that makes sense. So just to emphasize is that if we're looking in a quadratic and we're looking for the first difference, the n is the same number that you're going to use here. The number that's in front, right, when finding the difference is the same number that you use for this one. Hope that makes sense, right? So with that said, let me just clean this up. Or maybe let me not clean it up. Okay, let's clean it up. Right, so we know the fact that n is equals to this. Maybe let's put this inside a block. Sorry. Ooh, let's put this in a block. Right, so let's put this in a block. Right, so we know the fact that we're looking for t. We're going to use tn. So we know the fact that we're going to use tn is equals to -2n plus 3, right? Then we know the fact that our n is going to be equals to 35, because it's always the first one. So the smallest one, the smallest n is the one that we use for the first difference. So substituting is going to be T35, right? T35 is equals to -2. Then this is going to be 35, right? Plus 3. So therefore, when you punch that into the calculator, you're going to get the fact that T35 is going to be 67. So if we see it visually, is that between T35 and T36, right, the first difference, right, this is from the quadratic, right? So the first difference is 67, and this is the first difference. Hope that makes sense, right? Hope that makes sense. So that's how you would solve this question. So now what we're going to do, we're going to do 2.3. It says determine the expression for n terms, right, for the quadratic. So now we're looking for tn for the quadratic. So let's go up and take our quadratic, right? So this is going to be the quadratic, right? Copy and paste it. So this is going to be copy, cut. Okay, cool. So now we're going to just paste it here, right? So let's just paste it here, right? So I'm just going to take out the blue because we don't need that anymore, right? Then from here, taking out the blue is that when we're finding tn, right? So when we're finding tn, the formula is an squared plus bn plus c. The goal is to find a, b, and c, right? So let's put this inside a block and we're going to make it red, right? So that is the goal, right? So how do we find a, b, and c? Is that we're going to use from where? We're going to use it from here. So we need this, right? We need this. Okay, cool. Let me just do this, right? So is that we're going to use from here. This ones that I'm coloring, this is what's important, right? To find our a, b, and c. So let's make it green, right? Or let's make it blue. Yeah, green is fine, right? So those terms that I just showed always is the one that are important to find a, b, and c, right? So now the one from the bottom, right? Starting from the bottom, this is going to be 2a. That's the formula. Is equals to the one from the bottom. Then here's going to be 3a plus b. That's the equation. Then finally, this one is going to be what? It's going to be a plus b plus c. We always start solving from the bottom because of there's only one unknowns. Whatever that we get here, we substitute here. Whatever we get here, we substitute here. Hope that makes sense, right? So now let's solve it. So we see the fact that 2a is equals to -2, right? So therefore a is equals to -1, right? Because it's -2 divided by 2. Hope that makes sense. Then here we're going to have 3a plus b, right, is equals to 1. So it's going to be 3. Then this is going to be what? This is going to be -1, and this is going to be plus b, right? So this is going to be -3 plus b is equals to 1. So b is going to be equals to 1 plus 3, right? So therefore b is equals to 4, right? So now a plus b plus c, remember, is equals to -3, right? So it's equals to -3. So it's going to be equals to -3. Substitute a and b. So it's going to be -1 plus 4 plus c is equals to -3, right? So this is going to give me +3 plus c is equals to -3. So therefore c is equals to -3 minus 3, right? So therefore c is equals to -6, right? So we have our a, b, and c, right? So now we know the fact that Tn is equals to an squared plus bn plus c. So therefore Tn is equals to -1. So -1, we don't write the 1, it's negative, so it's going to be n squared. Then it's going to be plus 4b, 4n, right, because that's b. Then lastly it's going to be -6. So that is going to be our Tn, right? So that's going to be our Tn. Okay, so now we're going to do 2.4. It says explain why the sequence will never contain positive terms, right? Let's look at it. First, right? So first, let's just write it, the relationship between a quadratic. So let me just do this. Number 1, right? We know the fact that the relationship between a quadratic, so relationship between a quadratic, let me just do this. I should just think, let me just, yeah, the relationship between a quadratic sequence and a quadratic function, right? It's the same thing. So it's that you can take Tn and basically write it as a graph, right? So we can represent, right? So we can represent, so we, and I'm going to do that, we can represent quadratic sequence as a function. So when dealing with the quadratic sequence, just think about the fact that anything that's related to it, you can actually make it behaves as a function, right? So this is function. I forgot to add that. Yes, so this extended, yes, right? So I wanted to say we can represent a quadratic sequence as a quadratic function. So meaning all the properties of a quadratic functions now also are involved in Tn, right? So for something to never have positives, right? For something to never have positive, the reason why I said this about the functions because I want to draw a function, right? For something, so I'm going to just write it, is that we have a Cartesian, right? So we have a Cartesian. So let me just do this, erase this, right? We have a Cartesian, right? For something to never have what? To never have positive values. Remember the fact that in terms of Tn, this is your n, right? And remember the fact that all our n's are positive, so we don't regard the negative side, right? This is going to be your n, and this is going to be your Tn, right? So these are the values, aka the terms. That's your Tn, right? So for something to never have positive values is that when you're looking at the quadratic, right, it's going to be like this, right? Do you see the fact that this quadratic, right, this quadratic function, if this was y, it doesn't have any positive y's, it strictly has negative. And that is caused by what? This is caused by the turning point, right? So we see the fact that this is caused by the turning point, right? So the turning point here, right? The turning point, right? Which is the maximum, or if we're dealing with like, if we're dealing with like A being less than. But what I mean is that to find that, right, is that it's dependent on this value. It's dependent on this value, sorry. It's dependent on this value. So for strictly positive, or negative one, it's dependent on this. So here, this is for all negative terms. This is how the graph, and this is for all negative terms. So if this value is negative, right, if this value here is negative, and let me just put it in red. If this point here is negative, right, which is going to be the y coordinate of the turning point, y coordinate of TP of the turning point, right? If the y coordinate of the turning point is what? Is negative, right? Then that means the fact that this sequence, right, this whole sequence could never have any positive value, because this is where the positive values lies. So maybe let me just translate it to maybe if we're dealing with what, when it could never have any negative value. So let me just duplicate this, right, and just put it here, right? So for it to, okay, cool, let me just do this. I'll just draw it, right? So let's say now black. So we have this, right? And again, this is going to be our N, and this is going to be our Tn, right? So this is going to be our Tn, right? So let's zoom it in, right? So for it to have strictly positive values, do you agree the fact that our graph is like this? Again, do you see the fact that it's dependent on this turning point, right? Because if this turning point is positive, right, which is the y coordinate, right? So for the y coordinate, let me just make it in red. So if this y coordinate, right, is what? If the y coordinate is positive, that means the fact that our sequence strictly has positive. Do you see the fact that in the negative nothing exists? Hope that makes sense, right? So it's dependent on the y coordinate. I'm just going to say y coordinate of TP. So y coordinate of TP. So what is important here? Do you agree the fact that to find our answer is that we need to rely on what? We need to rely, what's this now? Sorry. Yes. We need to rely on what? We need to rely on the y coordinate, right? So let me just write the notes, right? For all positive. So if, okay, cool. So the y coordinate of the turning point. So the y coordinate of the turning point, right, tells us whether we have all positive, or all negative terms. Okay? So now we know the fact that if the y coordinate, right, so of TP, yes, right, y coordinate of TP is so y coordinate of TP, let me just do this, is what? Is greater than 0, meaning is positive, right? That means this is what? This is all positive terms. But if the y coordinate of TP is less than 0, meaning we have all negative. All negative terms. Hope that makes sense, right? So now, with that said, right, we need to find what? We need to first find, so to do that, we need to first find the x coordinate, then we need to find the y coordinate. So how to calculate? So now is how to calculate the y coordinate of TP. So now let's do that, right? So let me just underline this. So first we need to find the x coordinate, which is the x coordinate is the same as, with us, is going to be what? Is the x coordinate, which is going to be n, because remember it's Tn, right? Hope that makes sense. I'm translating into that. So it's going to be n, which is going to be negative b divided by 2a, right? Then we know the fact that, so I'm going to TP, I'm going to call it the n, which is the x coordinate, which is the same as Tn, right? Then now to calculate what? The y coordinate. So the y coordinate. So this is number 1 and this is number 2, right? So y coordinate. So the y coordinate of the turning point is basically equals to Tn, right? TP, right? Then this is going to be equals to, yeah, you're just finding that. You're just finding that using Tn, right? Hope that makes sense. So let me just maybe move this here because we don't need, yeah, because I want to put this whole thing inside a block. So let's put this inside a block. Okay. Yes. Right? So now putting inside a block, right, is that now we're going to find the y coordinate, right? So while finding the y coordinate, we know the fact that n, we need to look for n. So n is equals to negative b divided by 2a, right? So that's what we're going to find, right? Then after finding that, we're going to basically do what? We're going to find the y coordinate, right? So now going back, we know that a, and the nice thing is that we calculated, we know that a is equals to negative 1. And we know that b is 4. So let's substitute. N is equals to negative 1. And just to make you show the fact that you don't remember, you don't forget it, this is the same formula when calculating the turning point in the quadratic, right? So there's nothing different here. There's nothing special. It's the same thing, right? So we know the fact that that's going to be what? This is going to be, so it's going to be 2. Oh, good. I made a mistake. So it's 4, right? Then it's going to be 2. It's going to be negative 1, right? So now with that is that we're going to basically simplify it. This is the same as negative 4 divided by negative 2, right? Which is going to be the same as n is equals to positive 2, right? So we know that n is equals to positive 2. Now we're going to find the y coordinate, the one that we need to comment about. So the y coordinate, which is going to be equals to T2, right? So T2, so we know the fact that we already have Tn, right, is equals to what? Remember that our Tn is equals to negative n squared, right? Plus Bn, no, negative n squared plus 4n, then lastly it's going to be minus 6. It's going to be minus 6, right? Substitute n2, so wherever we see n, we're going to put 2, so we're looking for 2n, T2, sorry, so it's going to be negative 2, then squared plus 4, 2 minus 6, right? So it's going to be T2 is equals to what? This is going to be negative 4 plus this is going to be 8, then it's going to be minus 6. Punch that to the calculator. You're going to see the fact that your T2 is basically equals to what? It's equals to negative 2. We see the fact that our answer, right? We see, so therefore, the y coordinate, of TP is equals to negative 2, right? right? Since it is a negative number, that means all the terms are negative. All the terms in the sequence are what? Are negative. Which proves exactly what they want, right? Because we need to prove that it cannot contain positive, which is the same as like prove the fact that all the terms are negative. Hope that makes sense, right? So that is how you would answer this question. So now we're going to do question 3, right? It says the graphic below shows a dartboard, right, from which a pattern, right, so from which a pattern relevant to the different circles can be devised, right? So they go at the bottom, they give us more information. They tell us that the radii of the largest and moving consistently to the immediate within right circle is, then they give us the fact that the radius, meaning the biggest radius here, right, the biggest radius is going to be 18 centimeter. Then the radius of this one is a 6 square root 3, and the radius of this one is 6. Then they tell us more is that the innermost circle has a radius, so this one, right, the smallest one, has the radius of 2/3, right? So the first question, it says calculate the area of the circle. Calculate the area of the circles from a convergent geometric series. So we need to calculate R, because R tells us whether something is convergent or not. So that's what we need to do. But we're not dealing with radius. Do you see the fact that here they gave us radius, but we're not dealing with radius? They want us to deal with areas. So we need to basically find what? The area of the bigger circle, which is, we're going to call it area 1, then the second one, and the third one, right? So that's what we're going to do, right? So we're going to call it A1, A2, and A3, right? So we know the fact that area 1 is equals to what? The formula for area, remember, is what? Pi r squared, right? So we know the fact that the formula for area, so let me just say area, we know the fact that is equals to pi r squared, right? That's very important. So let's put it in red. So to calculate area 1, right, which is going to be the one with the radius of 18. So area 1 is basically equals to pi. Our r is 18, right, all squared, right? So this is the same as what? This is the same as 324 pi, right? So area 2, which is the same as pi, then r is 6 root 3, right? So as all squared, so 6 root 3 all squared is the same as 108, right, pi. Then lastly, it's going to be R3, what you call area 3, which is going to be pi. Then it's going to be 6 all squared. So this is the same as what? This is the same as 36 pi, right? So now forming a sequence of this one, right, is going to be the same as what? As 324 pi as being the first term, 108 pi being the second term, and 36 being the third term, right? And it continues, right, till the last circle. So I'm gonna call it, we don't know what is in, right, till the last circle. So I'm gonna just call it last, because I don't know what value it's within, right? So we know the fact that the last circle, right, which is the smallest one, is going to be pi. Then it's going to be 2/3 all squared. So this is going to be the same as what? As 4/9 pi. Hope that makes sense. So till the last term, which we don't know what is the end value for it, which is going to be 4/9 pi. Hope that makes sense, right? So now remember the fact that we want to check whether the fact that show the fact that the area is convergent. So checking for the fact that the area is convergent, we need to find R. So to check, wow. So to check to check that the area is converges, right? Converges is that we need to find R. So we know that the radius, right, is equals to T2 divided by T1. This is T2 and this is T1. Hope that makes sense, right? So we know that T2 is equals to 108 pi divided by 324 pi, right? So the pi's are going to cancel out. So when the pi cancel out, we left with just numbers, which is going to be 108 divided by 324. Punch that into the calculator, right? When you punch that into the calculator, you see the fact that the radius is basically 1/3, right? So for something to be convergent, is that convergent also means, like I just forgot, R needs to be between -1 and 1, right? So since our R is what? R is between -1 and 1. So that shows the fact that this is basically the area is actually convergent. Hope that makes sense. So that's how you would show the fact that the areas of the circles are convergent. So since, let's comment, since since R is equals to 1/3 and it is between -1 and 1, that means that the area is convergent. Converges. Yes, right? So that's how you would solve this question. So now we're going to do 3.1.2. It says calculate the number of circles in the sequence E forming the dartboard, right? So what we want is that we want to know how many circles there are in total, right? So one, calculating all of them. So you can't like necessarily count them, right? But remember the fact that we had a sequence E and this is our sequence E. So let me just copy and paste it. Copy, duplicate, cut, right? So I'm just going to explain using this, right? Remember the fact that this, we have the area of this, right? So we have the area of circle 1. So I'm going to call it circle 1, right? And this is circle 2. And this is circle 3. So what we're looking for is that how many circles that are there. We have already the area of the last circle, right? So we're looking for this in here, right? So we know the fact that here, this is circle 1, circle 2, circle 3. Since we have the areas, because they gave us the radius of the last one, is that we can use Tn, which is in our case is Cn, right, to find the area of the last one. Hope that makes sense, right? So now what do we need? We know the fact that Tn, right? Tn of a geometric. So we know the fact that Tn. So we know the fact that in our case, I'm going to call it Cn because circle, right? So, okay. So we know the fact that Cn is equals to basically Tn of a geometric. And we know the fact that Tn of a geometric is A at n minus 1, right? So we're looking for this n, right? And what do we have? We have this one. So this, we're looking for this n. Hope that makes sense, right? So with that said, is that we need A and what? We need A and R, right? So we see the fact that A, so let me just do this. Oh, sorry. We know the fact that A, right? We know the fact that A is equals to the first term, which is 324 pi. We know the fact that not D, so we know the fact that R, right? Remember the fact that we calculated R as being 1/3. So it's going to be 1/3 from the previous question, right? So now we can find what? We can find, we also know the fact that what? Cn or Tn, let me just call it Tn, right? It's equals to 4. Okay, let's just call it Cn so that because of I called it Tn there. We know that Cn, right, is basically equals to what? We know that Cn is equals to 4 over 9 pi. So pi, right? We know that, right? So now we know the fact that using Cn is equals to ARn minus 1. Let's substitute. This is the same as 4 pi divided by 9, right? Because we can take the pi to the numerator. And this is going to be A. So A, we know the fact that it's 324 pi, right? Then here is going to be R is 1 over 3. Then it's going to be n minus 1. So we want to make n the subject, right? So now we can, since this side, this is multiplying, to the other side is going to be dividing. So this is going to be the 4 pi divided by 9 divided by what? Divided by 324 pi is equals to 1 over 3. Then this is going to be n minus 1. So now let's sort out this, right? So this is going to be 4 pi. So it's going to be 4 pi divided by 9. We want to change the division to multiplication, so it's going to be 1 multiplication. So this is the same as divided by 1, right? So since it's the same as divided by 1, meaning it's going to be what? It's going to be 1 divided by 324, right, pi. So now what we're going to do, we're going to multiply numerator to numerator and denominator to denominator. We see the fact that 4 pi multiplied by 1 is going to give me 4 pi, right? And we see the fact that 9 multiplied by 324, right, pi is going to give me, we're going to multiply the 9 multiplied by 324, right, which is going to give me 2,916 pi, and this is going to be equals to 1 over 3 to the power n minus 1, right? So the pi's are going to cancel out. They're going to cancel each other. So we're going to have 4 divided by 2,916 is equals to 1 over 3. And this is going to be n minus 1, right? So now let's simplify 4 divided by 2,916. We see the fact that we're going to have 1 divided by 729 is equals to 1 over 3, right, to the power n minus 1, right? We see the fact that 729 can be written in terms of 3. So 1 divided by 729 is actually 3 to the power 6. So this is going to be 1 divided by 3 to the power n minus 1. Then we know something, right? We know the fact that anything to the power 1 to the power any number is still going to be 1. So meaning we can rewrite this as 1 over 3 to the power 6 is equals to 1 over 3. That's going to be n minus 1. Because we know the fact that 1 to the power 6 is the same as 1, right? Because any 1 to the power of any number can be still 1. Hope that makes sense, right? So now we see that the bases are the same. So we can do what? We can drop the base and equate the exponent. So this is the same as 6. So sorry. This is the same as 6 is equals to n minus 1. Take the 1 to the other side. This is the same as 6 plus 1 is equals to n. So therefore n is equals to 7, right? So now going back to the question, right? We see the fact that how many circles are there? So in total there are 7 circles because n is equals to 7. Hope that makes sense. So now we're going to do 3.2. It says given the series, and they gave us the series, and they say that they write down this into sigma notation. So sigma notation is basically taking this, because this is addition, but instead of saying plus plus plus, we're just going to write it like this, because this also means adding things, right? It's the same as series, but it's in sigma notation, right? So to write something in sigma notation, we need the following. We need that Sn, so sigma notation. So sigma notation, right? So sigma notation is the same as having the sum, right? And here, so let me just go down. So we need the sum. Then on top, we have to have a number. And that is the last term, right? The last term, which is n, right? And here's going to be n is equals to 1. Then here is going to be Tn, right? Our Tn for that sigma, right? So this is how you would write it in sigma notation. So let's go here. Okay, cool. So let me just erase this. This is what I want. Yes. Put this inside a block, right? So now let's understand our sequence, right? Our series. So we see the fact that we have two terms, right? Two terms. And what do we see? We see the fact that if I take just the first term, it creates a what? It creates what you call this, it creates a sequence or a series, right, on its own. Then if we take the second one, also it creates a series, right, on its own. So with this one is that the first one, right, so the first one, which is I'm gonna color coordinate it, so let me just even reduce, is that here, right, we're gonna have the blue ones, right, creating a what, creating a series, right. Then we're gonna have the purple one also creating a series, right? So now the sigma for this question is going to be what? It's going to be the following, right? It's going to be, so it's going to be the sigma for this one. So the sigma notation for this one. So our answer for this question, answer for this question, or what we actually calculating, it's going to be what? It's going to be the sigma notation. Let me just go up, erase this. So it's going to be the sigma notation. Then it's going to be the last term still. Then it's going to be n is equals to 1 always. Then it's going to be Tn. Remember the first one is the blue one. So it's going to be the blue Tn. So let's maybe call it blue Tn, right? So it's going to be the blue Tn. Then it's going to be what? It's going to be the purple Tn. Purple Tn. So that's what we're looking for this question. So let's put that inside a block, right? That's what we're calculating. So maybe let's put it a dark purple, right? So to finish this, we need what? We need the last term. We need the blue Tn and we need the purple Tn. So let's start with the blue Tn, right? So we're going to start with the blue Tn and we're going to highlight it, right? So we know the fact that this is going to be the blue. Okay, cool. Let me just erase this. Yes, right? So we're going to start with the blue Tn. So let me just increase this, right? So looking for the blue Tn, we know the fact that Tn, right? Tn is equals to what? Tn is equals to A plus n minus 1 d, right? So let's just extend it. We know the fact that Tn is equals to that, right? So we're going to need what? A and D, right? So we're going to take the blue one, right? We know the blue is 1, it's 5, it's 9, it's 13, right? So it's going to be 1. So the blue series is going to be 1 plus, it's going to be 1 plus 5, right? It's going to be 1 plus 5. It's going to be 9. Then it's going to be 13. Then it continues till what? Till 81. Right? So now we need to find the difference. We see the fact that if you say 13 minus 9, we're going to get 4. If you say 9 minus 5, we're going to get 4. If you say 5 minus 1, you're going to get 4. So we see that A is equals to what? Is equals to the first term, which is this one, which is 1. And we see that D is equals to what? Is equals to 4. So Tn for the blue one is going to be equals to what? What A? A is 1 plus n minus 1. And this is going to be 4. Then distribute the 4. So it's going to be 1. Then it's going to be plus 4n minus 4, right? So therefore Tn for the blue one is going to be what? It's going to be equals to what? It's going to be equals to 4n, right? And it's going to be minus 3. So that's going to be the Tn. Then we need the Tn for the purple one. So it's going to be Tn. So purple Tn. Right? So purple Tn. So let's do, let me erase this. I keep on taking that. Okay, cool. So we know, no, I want to highlight it. Sorry. So this is going to be for the purple Tn, right? So again, we need A, right? So we're going to take the sequence for the purple one is 2. So it's going to be 2 plus, so it's going to be 2 plus 6. I really hate that my Going back doesn't work. Plus 6, right? It's going to be plus 6 plus 10. It's going to be plus 10. Then plus, let's go up. It's going to be plus 14. Plus 14. Then it's going to continue. And it's going to be plus 1. It's going to be 82. Right? We see the fact that let's find our difference. So if you say 14 minus 10 is going to give me 4. If you say 10 minus 6 is going to give you 4. And lastly, if you say 6 minus 2 is going to give you 4. So we see the fact that A is equals to the first term, which is 2. Then D is equals to 4. So Tn for the purple one is going to be 2 plus n minus 1. Then it's going to be 4. Just repeat the 4. So it's going to be Tn is equals to what? Is equals to 2 plus 4n minus 4. Therefore, Tn is going to be equals to what? It's going to be equals to 4n minus 2, right? So that's what we have. So we have the purple and we have the blue. Then lastly, we need to find the last term, right? So using one of them, right? So I'm going to just use this one. I'm just going to use this recent sequencing, right? You can also use to find the last term. You can use this one. So the blue one or the purple one, because the purple one is the nearest one. I'm going to use that, right? So to find the last term is that this is going to be our Tn and we're solving for n, right? So finding, so it's going to be finding Tn, right? So we know, sorry, finding the last term, the last term. So from finding the last term, we know the fact that Tn, in our case, in this formula from the purple one, right? Maybe let me indicate from the purple one, from the purple series. You can also use the blue series. You can try it out for the blue series. You're going to get the same thing, right? So we see the fact that from the purple series, right, we see the fact that Tn is equals to 82. Then we already have Tn, so we're solving for n, right? So therefore, we know the fact that 82 is equals to 4n minus 2, right? So take the 2 to the other side. We see the fact that 82, right, plus 2 is equals to 4n, right? So when you have 82 divided by 2 is equals to 4n, right? We're going to have what? Now we're going to have 84. So let me just go up. Yes, we can go up. So it's going to be 84, right, is equals to 4n. So it's going to be 84 divided by 4 is equals to n. So therefore, we see the fact that our n is equals to 21, right? So we have a total of 21 terms, right? So since now we have a total of 21, so now we have a total of 21 terms, which is the last term, right? So now we're going to basically write our sigma. Remember? So I'm just going to take this from what our answer needs to look like. So I'm going to copy it and cut it. I'm going to go down. So we know the fact that it's going to be the sigma notation. So it's going to be the sigma notation. Then n is equals to 1. That's always going to be like that. Then we know the fact that we have a total of 21 terms. The blue sigma, right, is going to be 4n minus 3. So it's going to be the first bracket. It's going to be 4n minus 3. Then the second bracket is going to be 4n minus 2, right? It's going to be 4n minus 2. So it's going to be 4n minus 2. So now we're going to do 3.3. It says in the series a plus ar plus ar squared. And then it continues till infinity. The sum to infinity is 1. Then they tell us the fact that in the series where the terms are now squared, right, the above series, the sum to infinity is 5 over 6. Then they want us to determine the common r, meaning we need to calculate r. So now let's write down what we have, right? So for the first one, right, we see the fact that we have a series of a plus ar plus ar squared. And that continues, and we see the fact that s infinity is equals to 1, right? So we know that. But we know the fact that the sum to infinity, right, is equals to what in terms of formula? Is a divided by 1 minus r. So we already know that the sum to infinity is equals to 1. So this is the same as saying 1 is equals to a divided by what? 1 minus r, right? So here, just to emphasize, is that we already know that a is going to be just a because that's the first term, and r is going to be just r, right? And we can just solve for r just to show you, right? So solving for r here, we know that r is equals to t2 divided by t1, right? So I just want to show you the fact that it's still going to be r, right? So t2, we see the fact that this is the second term and this is the first term. So this is the same as what is a r divided by what? Divided by a. So the a are going to cancel out so that our r is r. Hope that makes sense, right? So now I'm just gonna take this to the other side, multiply this 2. So it's gonna cross multiply because this is the same as 1, right? So this is going to be the same as 1 multiplied by this, which is the same as 1 minus r is equals to a. And I'm going to call this equation 1, right? So that's that. Then the second information, they tell us the fact that the one that is equals to this sum to infinity is the terms of this one squared, right? Meaning the first one, remember, is a. So this is going to be a squared. So 4a squared plus the other one is what? It's AR. So it's going to be AR all squared plus then it's going to be AR squared, right? Do you see? AR squared, but also squared. And this is going to continue. And we see the fact that the sum to infinity for this one is what? It's 5 over 6. So we know the fact that the sum to infinity is 5 over 6. Hope that makes sense, right? So now with this one is that we also know that the sum to infinity, the formula is a divided by what? Divided by 1 minus r. So here we need what? We need the following. We need what a is. We see that our a is a squared because this is the first term for this one, for this information. Hope that makes sense. And we see that r is equals to t2 divided by t1, right? We know that t2 is this one and t1 is this one. So this is the same as what? As a, right? So it's going to be a r all squared divided by what? By a squared, right? So let's simplify this. So simplifying this is the same as what? It's the same as a squared r squared divided by a squared. The a squared are going to cancel each other. So therefore, we're going to have what? We're going to have the fact that it's going to be r squared. So our r here is going to be r squared. So let's substitute here, right? We know the fact that this is going to be a squared, right? A squared divided by 1 minus r squared. And this is going to be the sum to infinity. But we know that the sum to infinity is what? It's 5 over 6. It's equals to a squared divided by 1 minus r squared. Hope that makes sense. And I'm going to name this equation 2, right? So now we already know that equation 1 is in terms of a. So what I'm going to do is that I'm going to substitute 1 into equation 2, right? So we know the fact that equation 1 is what? It's 5 over 6. So we know the fact that it's 5 over 6 is equals to what? To a squared divided by 1 minus r squared, right? So now wherever I see a, right, because this one is in terms of a, I'm going to put 1 minus r. So let's do that. So it's going to be 5 over, so let me just unzoom it a little bit. So it's going to be 5 over 6 is equals to 1 minus r, but all squared, right? And that's going to be divided by 1 minus r squared. Then I'm going to write this one into 2 brackets, right, because of the squared. Then I'm going to factorize this. And this is a difference of 2 squared, right? So this is going to be 5 over 6 is equals to 1 minus r. That's going to be 1 minus r. And this whole thing is going to be divided by what? Difference of 2 squared. So it's going to be 1 minus r. Then it's going to be 1 plus r, right? So that's what we're going to have. Now, we see the fact that this and this are going to cancel each other. So this and this are going to cancel. So we're going to be left with 5 over 6 is equals to 1 minus r, then 1 plus r. Then we're going to cross multiply, right? So we're going to cross multiply. So when we cross multiply, we're going to have 5 multiplied by 1 plus r is equals to 6 multiplied by 1 minus r. distribute the 5 and 6, right? So we can simplify it. So when we simplify it, we're going to have what? We're going to have the following. We're going to have 5 plus 5r, and this side we're going to have 6 minus, sorry, it's going to be 6 minus 6r, right? So now taking the ones with the r to the one side and the ones without the r to the other side, so it's going to be 5r. So this is going to be 5r plus 6r. Then this side is going to be 6 minus 5. So we're going to have 11r is equals to what? Is equals to 1. Therefore, r is equals to 1 divided by 11. So that's going to be your r for this question. So your r, your common factor, is going to be 1 over 11. So now we're going to do functions. We're going to do question 4. So the question says the graph of the function f of x, which is, this is a hyperbola. So meaning it has vertical asymptote and horizontal asymptote, right? And they gave us that h of x, which is a linear, is sketched below, right? So now let's understand the graph on its own before we even answer the question, right? We see the fact that we have x is equals to -2. This is the vertical asymptote, right? And this is for f of x, right? So f of x has the asymptote. So this is the vertical asymptote and is equals to -2. -2, this -2 is basically p, but is always the opposite. So meaning here p is equals to, since here is -2, it's going to be +2. Hope that makes sense. The number that goes here is always opposite to the one that you sketch on the graph. Hope that makes sense, right? And we see the fact that we have a horizontal asymptote, which is this one, is y is equals to -1. Then this one is q, right? And with q, so let me just do this. With q, right, with q is that it maintains its sign. So here we see the fact that q is equals to -1. Hope that makes sense, right? Then we have a point of intersection. Do you see this point here? It's going to be what? The x coordinate at this point is -2 because of it's from the vertical, right? Then the y coordinate is going to be this one, which is going to be -1, right? Hope that makes sense. So that's what we have, right? So that's what we have. And we see something. We see the fact that this line h, right, intersects where? Intersects at that point of the asymptote where the vertical and horizontal asymptote intersect. And we see the fact that we have another extra point on f of x, which is just the hyperbola, which is this one, right? So with that said, is that now let's answer the questions. The first one, they say the fact that write down the values of p and q. We know that p, right? We know that p is equals to what? We know that p is equals to 2 and q is equals to -1. So that's how you would answer the first question. So now we're going to do 4.2. It says calculate the value of a. So we know the fact that a is from f of x. So we know the fact that we have f of x is equals to a divided by x. Let's go up. X plus p plus q. But we already know what p and q is, so let's update it. So it's going to be f of x is equals to a divided by x plus 2, then it's going to be -1. So we need the value of a. If we go back, we see the fact that we have a coordinate here. So since now, if we substitute the coordinate, a is going to be the only unknown, we can solve it. So we're going to substitute. The coordinate, which is the coordinate is -4, is to what? Is to -5 over 2. So it's going to be -5 over 2. So let's substitute it, right, into f of x. So let's do that. So we know the fact that's going to be -5 over 2. It's equals to a divided by -4 plus 2 minus 1, right? Take the 1 to the other side. So it's going to be -5 divided by 2 plus 1, right, is equals to what? It's equals to a divided by, then this is going to be -4 plus 2, so it's going to be -2, right? So let's clean up this side, right? So when you say 5 over 2, so when you say -5 over 2 plus 1, you're going to get what? You're going to get 3, right? Negative 3 over 2, which is going to be equals to a divided by negative 2. So now we're going to cross multiply, meaning this and this are going to multiply, and this is going to multiply. So it's going to be negative. I'm going to take the negative on top, so it's going to be negative 3 multiplied by negative 2, which is going to be 2 multiplied by what? 2 multiplied by a, right? So negative 3 multiplied by negative 2 is going to give me positive 6 is equals to what? To 2a, right? So now when we say we're going to divide both sides by 2, so it's going to be 6 divided by 2 is equals to a. Therefore, a is going to be equals to positive 3. So that's how you would find your a. So now we're going to do 4.3. It says write down the domain of f, right? So the domain, write down the range of f, right? So here's the formula for writing the range. So it's going to be the range, right? So the range is going to be always y is an element of real numbers. Then it's going to be what? It's going to be y is not equals to q. So what is important here is finding q. So let me put this in a block, right? So now to find our range, we need to find q. So we're going to go and check what q is. Remember the fact that our q value is negative 1. So we know the fact that it's negative 1, right? So therefore, our range for this one, right, is going to be what? It's going to be y is an element of real numbers. Then it's going to be y is not equals to q is negative 1. So it's going to be negative 1. So that's how you will solve this question. So now they say determine the equation. 4.4, it says determine the equation of the line of symmetry for f, meaning it's still the hyperbola, right, for when m is less than 0 in a form of y. So we're looking for the equation of the symmetry. So we have two equations. We have one with the negative and one with this positive. So the one with the positive gradient, so positive gradient, right, which in this case is the same as m is greater than 0. The equation is y is equals to x plus c, right? Then we have one with the negative gradient, right? Negative gradient, so negative gradient, right? Which is the same as m is less than 0. And that the equation is y is equals to what? To negative x plus c. So the goal is to find c, right? How do we find c? To find c, so to find c in both of them, to find c, right, we substitute this coordinate, which is going to be p is to q, right, meaning the intersection of p and q, right? So the vertical asymptote, the intersection of the vertical asymptote. So let's put this down. Let's go, right? The intersection, I mean this point here. So that is the point. Remember the fact that always opposite to this one for p is always opposite. So we need to substitute this to basically solve for it, right? So in this case, in our case, it's going to be what? Is that we know the fact that for the negative gradient, right, is that we're going to use what? We're going to use y is equals to negative x plus c. Then we're going to substitute, right, which is we're going to go up. What is the intersection? Negative 2 to negative 1. So it's going to be negative 2 is to negative 1. So it's going to be negative 2 is to negative 1, right, into y. So it's going to be what? It's going to be negative 1 is equals to negative. Then it's going to be negative 2 plus c. So this is the same as what? This is the same as negative 1 is equals to 2 plus c. So it's going to be negative 1, negative 2 is equals to c. So therefore, we see that c is equals to negative 3. So now, therefore, our equation is going to be y is equals to negative x, right, minus 3. So that is going to be the equation. So now it says write down the equation of the asymptote for this function, right? So basically, we need to find the new p and q for this function. So just to make it simple, I'm going to let this function, right, equals to maybe h of x, right? So that we can find the new p and q of h of x. So we know the fact that so we're going to say let h of x be equals to f at x plus 4 1 over 2, right? So we know that, right? So we know that. So now what we're going to do is that we're going to rewrite h of x in terms of the asymptote so that we can see it. We're going to rewrite h of x in this form, right? So we know the fact that the following, we know that f of x, right? So we know the fact that f of x, because we need f of x. We know that f of x is equals to what? We solved a, right? We know that f of x is equals to, let me just rewrite it. It's going to be a divided by x plus p plus q. But we have a, p, and q. So we know that f of x, right, is equals to what? Let's go up. We know that it's equals to 3. A is 3. Then we know the fact that it's going to be what? It's going to be 3. Then it's going to be x plus 2. That's going to be minus 1, right? So we know that, right? So now let's sort out this h of x. So we know the fact that if that's the case, then h of x is basically equals to this, right? But now wherever we see x, right? Wherever we see x, we're going to substitute this whole thing. Because you see the fact that the whole x is replaced by this thing. So we know the fact that it's going to be what? It's going to be 3 divided by what? Divided by. Then this x is going to be now the new x, the x here, right? So it's going to be what? It's going to be x plus 4 over 2, right? And this is going to be 4 over 2. Then this is going to be plus 2, right? And this is going to be minus 1. Hope that makes sense. So let me just show you what I did in highlighter so you can see. This is basically this now. Because of that's how this one looks. Hope that makes sense, right? So now we're going to basically clean up this because we see the fact that only the denominator is the one that's affected. So it's going to be 3 divided by what? Divided by x plus 4 1 over 2 plus 2 minus 1, right? So this is the same as having 3 divided by what? Divided by x. Then this is going to be plus 6 1 over 2 minus 1. Right? Then from here, right, remember the fact that we're looking for the equation. So meaning from here, this one is going to be our new equation, and this is going to be the new equation. So our asymptote, right? So our asymptote here. So our asymptote, let me just say our asymptote for h of x. So our asymptote for h of x, which is what they want, right, is going to be what? So our vertical asymptote, so our VA is going to be what? It's going to be x is equals to, it's going to be this one, but the opposite sign, right? So it's going to be this, it's going to be minus 6 1 over 2. Remember the fact that when we take it out, it becomes opposite from when it's inside in the formula. Hope that makes sense. Then our horizontal asymptote is going to be y is equals to this one, which is going to be negative 1. And that's how you would answer this question. So now we're going to do question 5, right? It says, given, then they gave you f of x, which is a quadratic, right? Then g of x, which is a linear function, and h of x, which is a logarithmic, right? So the first one says, write down the coordinate of the turning point of f, right? So we know the fact that it's in terms of the quadratic ax squared plus b x plus c. So we're going to use the formula. We're going to use this formula, right? X is equals to negative b divided by 2n to basically find the turning point. So finding the turning point, we know the fact that it's going to be x is equals to negative b divided by 2a, right? So we need a. So a is equals to this one, and our b is equals to this one, the coefficient, which is going to be 1 here, right? Negative 1. So a is going to be positive 2. Then b is going to be equals to what? To negative 1. So let's substitute. So we see the fact that x is equals to negative 1 divided by 2. Then it's going to be what? 2, right? So this is the same as x is going to be equals to what? Our x is going to be equals to 1 over 4, right? So, but remember the fact that this is the x coordinate. To find the y coordinate, to find y, it's basically equals to f of 1 over 4, right? So we have f, we know the fact that it's 2, so it's going to be 2. Wherever we see x, is going to be 1 over 4 now. And this is going to be all squared. This is going to be minus x, so it's going to be minus 1 over 4, right? then it's going to be minus 15. So it's going to be minus, sorry. So it's going to be minus 15. So it's going to be minus 15, right? So now punch that into the calculator. You see the fact that y is equals to what? Y is equals to negative 121 divided by what? Divided by 8. So the turning point, TP, is basically 1 over 4 is to negative 121 divided by 8. So that is the coordinate of the turning point. So now we're going to do 5.2. It says show that the x-coordinate of the x-intercept, right, of f's is are negative 5 over 2 and 3 respectively. Then here, what do we see? We see the fact that they just want us to solve the x-intercept, right? So showing is that we need to basically solve for the x-intercept. So we know the fact that the x-intercept, right? We know that the x-intercept, we need to let y equals to 0, which y is also f of x, right? So we know the fact that f of x in our case, right, is equals to what? Is equals to 2x squared minus x minus 15, right? It's going to be minus 15, right? So now if let y, which is also f of x, equals to 0, so 0 is equals to 2x squared minus x minus 15, right? So now we're solving, we need to factorize it. So when we factorize, we're going to see what? We see the fact that we're going to have 2x, right, plus 5, and also it's going to be x minus 3. You can also use the quadratic formula to basically factorize here, right? So equate both bracket by 0. So we're going to have what? We're going to have 2x, right, plus 5 is equals to 0. Or we're going to have x minus 3 is equals to 0, right? So therefore, it's going to be 2x is equals to what? Is equals to negative 5. Then we're going to have x is equals to negative 5 divided by 2. This side is going to be x is equals to positive 3. This is exactly what we have here. So that's basically solve this question. So now what we're going to do is that we're going to sketch, right? We're going to do 5.3, which is says sketch the graph f of x, g of x, h below, and clearly indicate all the intercepts, right, and the x's, what you call this, the x's, with the x's and the asymptote where necessary, right? So we're going to start by sketching. So sketching h of x. So I'm going to do it individually, right? So we're going to start with sketching f of x. We see that f of x is a quadratic, right? So we see the fact that it's a quadratic function. So it's basically sketching a quadratic function, right? So what do we need with sketching a quadratic function? So let me just highlight, underline this. We need the following. One, we need the shape. So we need the shape. So the shape, so we need a, which gives the shape, right? So we need a, which gives the shape. So when a is greater than 0, we know the fact that it's a smiley face, and when a is less than 0, it's a sad face, right? So that's what we need. So that's the first part, right? The second thing we need, what is that we need the x and the intercepts. So both the x and y intercepts, right? Then thirdly is that we need the turning point. Turning point, not point, right? So let's put this inside a block. Right? So now let's put all of them, right? So let's start with a. We see that a is equals to what? Let's go up from our function. A is equals to positive 2. So a is equals to positive 2. Right? So a is equals to positive 2, which is greater than 0, meaning we're expecting to see a smiley face. Number 2, we need the x-intercept, the x and y intercept, because it's intercept. So we know that the x-intercepts, right, we already calculated them. Remember the fact that here is negative 5 over 2. So it's negative 5 over 2 is to 0. And the other one is what? Is 3. So it's positive 3. is to 0. Then now we need the y-intercept, right? So we see the fact that we have f of x, and our f of x is 2x squared minus x minus 15. Let's just check because I want to make sure, right? So this, do you see the one, this constant gives us the y-intercept. So now, therefore, our y-intercept now is going to be what? So our y-intercept here is going to be 0 is equals to negative 15. Hope that makes sense, right? So since we have everything that we need, I'm going to just put it here on the side and we're going to sketch the graph. So we're going to sketch the first graph, right? So we see the fact that we need 15, so it's going to be below. So we need more. And wait, the turning point. Oh, sorry. So number 3, we need the turning point. So we know the fact that the turning point, we calculated it, is 1 over 4. Is to what? 1 over 4 is to negative 21. So it's going to be negative 21 divided by what? Divided by 8. Yes, divided by 8. So what I like doing is that if I have fractions, I like basically changing them into values, right? So let's change them to values. So we know the fact that 1 divided by 1 divided by 4 is going to give me 0, 0.25. So this is equivalent to 0, 0.25. And negative 121, so it's negative 121 divided by what? Divided by 8 is the same as having negative 15, 125. The reason why I like doing it like this, so that I can see it on the graph where it is, right? So this, let's put it here. This is the same, right? So now let's sketch it. So we see the fact that in terms of the y, right, is that we have a negative 15 and we also have a y-intercept which is 15, right? So we see that. So meaning it's more on the negative side, right? So since it's more on the negative side, I'm just going to do this. Where is it? Yeah. So like this, right? So now let's put the points there, right? So we see the fact that it's a smiley face and it has 2 coordinates. So let me just do this. Am I going to be able to get the 15 somewhere here? I hope so, right? So we see the fact that we have what? We have negative 1. So it's going to be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Ooh. Negative 9, negative 10, 11, negative 12, 13, 13, okay, then 14, negative 14, then negative 15, then negative 16, right? So we have that, right? Then after having that is that we know the fact that here is going to be positive 1, positive 2, and positive 3, right? Then let me just draw a ruler. Take a ruler. And let me just do this. This is 1, 2, 3, 4, 5. 1, 2, 3, 4. Right, hide it. Yes. So we know the fact that this is going to be 1, 2, 3, 4, and this is going to be 5. It's going to be negative 1, negative 2, negative 3, and negative 4, right? So now let's put in the points, right? So we're going to start with the x-intercept. So 5 over 2, right, is the same as having 2 over 2.5. Yes, 2.5, right? It's the same as of 2.5. To 2.5 is going to be 5 over 2, so it's a negative, so it's going to be 2.5. So it's the same as being between these two, right? Then the other one is just 3, so it's going to be here, right? Then we see the fact that the y-intercept is going to be here, right? And we see that the turning point is somewhere, it's 0, 0,5, so it's 0, 0,25, so it's going to be somewhere here. So let me just draw a dotted line going down, so you know the fact that it's somewhere here. Let me just do this dotted line, right? It's going to be somewhere here. Okay, cool. So yes, somewhere there. Let me delete this. Somewhere here. Yes, somewhere there. Then 15,125, I think it's somewhere here too. So it's here. So it's somewhere here, right? So it's somewhere here, right? Then now draw the turning point. So we know the fact that it's going to be, the graph is going to be like this, just like this. Then it's going to go up. Yeah, then it's going to go up here. Also going up like this. So that covers what? That covers f of x, right? Now we're going to be sketching, right? So we're going to be sketching. So we're going to be sketching. Remember, we're sketching all three. So we're going to be sketching g of x. So we see the fact that g of x, let's go up, right? We see that g of x, this one is a linear function. So this is the same as sketching a linear function. So a linear function. So let's underline this. If we're sketching a linear function, right, we need the following. We need a, which is the shape, So shape. So we know that when a is greater than 0, then the graph is going to be what? It's going to be increasing. It's going to be like this. And when a is less than 0, then our graph is going to be decreasing. So it's going to be something like this, right? Then 2, we need the intercepts, and that's it. So that's it, right? So with that said, right? So with that said, is that let's put this inside the block and find what we need, right? So we see the fact that 1, a is equals to what? A, let's go back. So I'm going to write g of x here so that everything is easy. So g of x here is equals to, so let's go up. So we see the fact that g of x is equals to 3x. So it's going to be 3x. 3x go up. 3x minus 9 over 2. Minus 9 over 2. Right? So we see the fact that a in our case is equals to 3, which is greater than 0. So we're expecting our graph to look like this. Right? Then we see the fact that this is number 1. Number 2, we're looking for intercepts. We see the fact that our x-intercepts, we need to let y equals to 0. So when we do that, y and g of x is the same thing. So it's going to be 0 is equals to 3x minus 9 over 2, right? So therefore, it's going to be what? It's going to be, take it to the other side. So it's going to be 9 over 2 is equals to 3x, right? Divide both sides by 3. So it's going to be 3 divided by 9 over 2 divided by 3 is equals to x, right? So when you say 9 over 3 divided by 2, right? 9 over 3 divided by 3, sorry, it's equals to the same as 3 over, it's going to be 3 over 2 is equals to x. So our coordinate is going to be 3 over 2 is 2, 0, right? So now looking for the y-intercept. So y-intercept, right? If we go back, this gives us the y-intercept. So this gives us the y-intercept, right? So therefore, our y-intercept is going to be what? It's going to be 0 is to negative 9 over 2. So it's going to be negative 9 over 2. So this in decimal form, right? This in decimal, so 3 divided by 2. So 3 divided by 2, Anna, in decimal form is the same as what? Is the same as what? Is the same as 1,5 is to 0. Then this one in decimal form is the same as what? So when you say 9 divided by 2, right, in decimal form is the same as 4.5. So this is going to be 0 is to negative 4.5, right? So now let's sketch this one, right? So sketching this one is going to be what? It's going to be our intercept. So it's going to be negative 0 is to negative 4.5. So negative 4.5 is somewhere here. So it's going to be here, right? That's negative 4.5. And the other one is going to be 1.5, positive 1.5. So it's going to be somewhere here. So our line, and I'm going to just make it a different color. So our line is going to be in blue, which is going to be g of x is going to be this two connecting. Okay, cool. So wait. This sucks. Right? Yeah. Okay, let's connect it again. So we know the fact that it's going to be where? It's going to be 4.5. So it's going to be here. And it's going to be 1.5, which is going to be somewhere here. So the line that I'm looking for is going to be a line going like this. It's going to be blue, so it's going to be line going through it, this and this too. Right, let's fix that. Let's fix that. Yes, goes like this, right, and goes like this, goes like this. Just wanted to touch properly. Yes, so that is the line, right? So this is going to be your g of x. So this is g of x, right? So this is going to be g of x, and the black one, remember the fact that that's f of x, right? So now we'll be sketching. Let's go up. I just want to make sure. So now we'll be sketching h of x, which is a log function. So we're going to be sketching h of x, right, which is a log function. A log function, I'm going to be basically looking at it from a perspective of an exponent, right? So with the log function, we need the following, right? We need a, so all of them, we all need a, which is the shape, which say, okay, wait, before even doing that, right? With the log function, we basically gonna look at the exponential. So we're gonna change the log into the exponential, right? Then from there, we're gonna like switch it up. Hope I'm making sense, right? So let's see the relationship between the exponential and the log, right? So the relationship between the exponential and the log, right? So it's gonna be the relationship, right, between exponential. Ooh, I hope I spelled it right. Yes, let's fix that. Exponential and log, right? So I'm going to look at it from a perspective of sketching an exponential, right? So if we have an exponential, which is, I'm going to call it xp, and this side we have a log, right? So first we need to understand the exponential, because that's the one that we have, right? That's the graph that we understand. We know that the exponential is made out of this, which is going to be y is equals to a multiplied by b to the power x, right, plus p, right? Then this is going to be plus q. But when sketching the log, we do not care about the p and q. Honestly, we do not care about that. But the only thing that we care about is that we care about y is equals to a multiplied by b to the power x. That's the only thing that we care about, right? So this is what we care about in this form. So in this form, this is the form we care about. And this is the only form that we care about when we're dealing with logmatic, right? Because switching it from exponential to logmatic, they only want it in this form. They don't care about the p and the q. Hope that makes sense, right? So let me just put that inside a box. Then with that is that when drawing our table, right, we're going to be looking at a and p, right? We're going to be looking at a and p. That's the only thing that we're going to be looking for. And the only thing that we care about is also the x-intercept. And I'm going to show you what is the x-intercept, because it's going to be the same throughout. Hope that makes sense, right? So let me just draw this table. So our a, right? So our a, we always start with b actually. Our b, right, for logmatic is that if b is greater than 1, right? So if b is greater than 1, we know that our graph is what? Our graph is going to be an increasing function, right? So meaning here, if our b is also equals to, is greater than 1, then our graph is going to be the same thing, right? Do you see the fact that here it's increasing here on the what? On the x-axis, on the positive x-axis, that it's going up. So here it means the fact that it's going to be increasing. So it's going to cut here, right? Then it's going to be increasing. So on the positive again. Do you see the fact that it's cutting the positive what? It's cutting the positive yx, meaning here it's going to cut the positive yx, then it's going to be increasing on the positive yx. So it's going to be like this. Hope that makes sense. So it's going to be like this. So that's when b is what? That's when b is basically when b is greater than 1. Then a depends, oh sorry, we still need b. When b is between, now our b is between 1, y is between 0 and 1, right? Then our graph is going to be decreasing. So it's going to be like this, right? It's going to be like this. So our graph is going to be like this. And also for this one, it's going to be the same thing when it's between these two, right? Our graph now is going to be like, it's going to be the same thing, but it's going to be like this. Hope that makes sense. And remember the fact that here it's on the positive yx, meaning here, since the log is the inverse of it, it's going to be on the positive xx. Hope that makes sense, right? So, but that's how the graph is going to be. Then remember the fact that when sketching the graph, is our a depends on b, right? So with that said, right, is that if b is greater than 1, right, and a is greater than 0, and it's going to be the same thing for this side. So let me just maybe, yeah, so it's going to be the same thing for this side. So duplicate, it's going to be the same thing for this side. And maybe let's put that into a block. Let's do like this, or maybe let's just underline it like this. No, not blocks, do like this so that we can separate. Yes, yeah, right? So we're going to look at the situation. Then our graph for this one, right, would be like this. But very important is that it's going to be the flip. So since it's positive, it's going to remain the same. So it's going to maintain its shape like this, right? then meaning the fact that also this one is going to be here. So it's going to maintain its shape. I don't like the fact that my graphs are untidy, to be honest. Let me just draw it like this, right? It's going to maintain its shape, so it's going to be like this, right? So it's going to be like that. Hope that makes sense, Anna? So we have that, right? So now let me just underline again. So now it's taking the same condition, right? So we're going to be taking the same condition, the if, but now we're going to be sketching for when it's what? So let me just delete this, right? So now instead of what? Instead of x greater than 0, it's going to be x is less than 0, right? So same thing with this side. So let me just extend this, right? So same applies here. It's going to be the same thing for the logmatic, right? So let me just duplicate it. Yes, right? So let's sketch that one, right? So when we sketch this one, right, is that now, let me just do this one. So it's going to be like this. So it's going to be like this, right? So it's going to be exactly this graph, right? But it's going to be on the negative y-axis. So it's going to be like this, right? Then this one, meaning it's going to be what? It's going to be this graph. Sorry. Yes. Let me just draw the proper one. Okay, cool. So this one is going to be this graph, but on this side. So it's going to flip on the other side. So it's going to be like that. So it's just going to be that one, but it's going to be like that. Hope that makes sense, right? So now I'm going to do the same thing for what? I'm going to do the same thing for when now we have this condition, when B is this condition, right? So let me just do this. So when B, if B, so this is if B, but now B is between 0 and 1, and A is greater than 0. So let's do this, duplicate it, right? So let's draw the graph first, this one, right? So we know the fact that this, right, is going to be a reflection of this, exactly like this, nothing changes, right? So it's just going to be that graph. So it's going to be just like this. Then this one is going to be exactly what? It's going to be exactly this without changing it, right? So it's going to be that one without changing it. So it's going to be this one without changing it, right? So now I've updated the table, and with the table is that we have the conditions, right? But now I want to talk about two important features, which is one feature is gonna help us with entering, sketching the graph, and the other one is gonna just help us later on, right? So I'm just gonna create another table, right? So I'm gonna create another table, and I'm gonna call it features. So let me just go back to black. So I'm gonna call it features. So features, right? And we have the exponential. So we know the fact that we're gonna have, and there's two features that I care about, right? So let me just do this. Yes, so it's gonna be features. So it's gonna be two features that I care about, and here's gonna be the exponential, right? Which is gonna be what? Which is gonna be y is equals to, so it's going to be y is equals to, then it's going to be b to the power x, right? Very important, we're dealing with the features. Before I even just let me just say log, and I'll just comment what I want to say, which is going to be log, right? Log b x, right? So very important with the features, right? The features that we care about, and this is very important for dealing with logs, right? The minute they want the inverse of an exponential, right, is that the features that only that we care about, it's when, so let me just write it here and I'll put it in a block, right? When dealing with log, two things are important, right? Is that our a is always going to be equals to 1, right? Our A will always be equals to 1, right? So our A will always be equals to 1. What changes is going to be the B. So make sense is that our A is going to be always equals to 1. Then our P is going to be 0. And our Q is going to be equals to 0. They will never give you an exponential function like this where our A is negative and also we have a P and Q. Will never. Every time it's going to be in this form, the only thing that changes is our P. So that is why I wrote it in this form, because the x-intercept and the x-intercept and the domain is going to remain the same looking at this, right? Hope I'm making sense. So let's put this in here, right? Okay. So now, with that said, is that the first feature that I'm gonna talk about here is the intercept, right? So it's the intercept, right? So here, the intercept that we have on the function, right, when B, let's take the fact that our A is positive, right, is that we see the fact that we have what? We have the y-intercept, right? And if, very important, if our A is positive and our P and Q are equals to 0, then this value is always going to be what? Is always going to be 0 is to 1, right? Hope that makes sense. Meaning in this form, right, our y-intercept, because we see the fact that that's the only thing that exists here, right, is the y-intercept. It's always going to be what? It's always going to be what? It's always going to be 0 is to 1. Hope that makes sense. But since this, right, is the inverse of this, meaning we swap our x and y, that means the fact that the y-intercept becomes the x-intercept now, right? And now the coordinate for that, we're going to swap them. So it's going to be 1 is to 0. Hope that makes sense, right? So this is what we're going to use for sketching, right? So now let's talk about the domain and range, right? So we know the fact that, so I'm going to say here, domain and range, right? So we know the fact that the domain here, right, becomes the range here. So for this type, right, what is the domain, right? So the domain for an exponential, it exists everywhere here, right? Since it exists everywhere here, meaning it's going to be x is an element of real numbers, meaning that this is going to be now y is an element of real numbers. Hope that makes sense, right? Then let's talk about our domain and range again. So here I'm just going to say our range here. And this is going to be the case always for this one, where I'm going to emphasize it again, where A is equals to 1, positive 1, and P and Q are 0. Hope that makes sense, right? So with that said, is that we know the fact that our range here, right, is going to be what? Let's look at our range here. It's going to be from 0, which is the asymptote, going up, right? So it's going to be what? It's going to be y is greater than 0. And we do not include 0 because of 0 is the asymptote. Hope that makes sense. Then therefore, this becomes our domain for the inverse, which is the logmatic, which is going to be x is greater than 0. Hope that makes sense, right? So let me just extend this. Okay, cool. So let me just extend it a little bit. And we're going to create a table. I'm just going to create a table outside, right? So that's the features that we care about when we're dealing with inverses and logmatic. And now we're going to sketch the graph using the information that we have on it. Now, sketching h of x, which is this one. So the first thing that we care about is just b, right? So we see the fact that b needs to be between what? We see that our b in our case is 1 over 3, meaning b is between 0 and 1. And also is that our A is positive here, right? So we see the fact that our A is positive. So we see the fact that this is where our condition lies, right? So we know the fact that this is where our condition lies. So let me do this. So we see the fact that this is where our condition lies, right? Then meaning we need to draw the logmatic, meaning this is how the shape needs to look, right? Then looking at the shape, right, is that we see the fact that it has a x-intercept, right? And we already know that the asymptote is 0. So we have an x-intercept. So since we have an x-intercept, we already know the fact that the x-intercept is from here, from the features, which is going to be this one, which is 1:0, right? So we know the fact that our x-intercept, and this is how the shape is going to look. Hope that makes sense. So now let's go and sketch it, right? So we're going to come here, we're going to put the x-intercept. So what I'm going to do is that I'm going to make it in green. We know that the x-intercept is going to be here. We know that the x-intercept is going to be here, right? And the shape is what? It's flat on the positive y-axis, and it increases on the positive y-axis. So let's do that. So let me just do that, right? So we know the fact that it goes like this. So that is what? This is going to be what? This is going to be our h of x. And that's how you would sketch all three graphs. Hope that makes sense, Anna. So now we're going to do 5.4. It says, if the point H is on the graph G and the point R is in F, such that the abscissa of both points is 4, right? Determine what? Determine the length of HR. So now, what is new? Is new word, right? Is abscissa. Let's understand what is abscissa. Abscissa just means, which is very annoying because they could have just said the x coordinate, but abscissa is another word for x coordinate, right? So it's another word for x coordinate. So if we needed to reread this question, it says, if the point H, right, which is on G, and the point R, which is on F, such that the x coordinate of both is 4. So meaning does H and R share the same x coordinate, which is 4, then we need to determine the length of HR, right? So we see the fact that point H, right, has what? Has a coordinate of 4 and YH. We do not know the H. And R has the coordinate of 4 and YR, which we do not know R, right? But this is from f of x, right? No, sorry. H is on g of x, right? And R, right, they tell us is on what? Is on f of x. The nice thing is that we both have g of x and h of x, so we can find the y and we can find this length. Hope that makes sense, right? So finding the complete, so first we need to find the complete, complete coordinate. Imagine complete. Find the complete, yes, complete coordinate, right, for H and R, right? So that's what we're going to do. So for H, we're going to substitute, right? We're going to substitute x equals to 4 into g of x, right? So we're basically looking for g of 4, right? So y is basically equals to g of 4. So y h is equals to g of 4. So we know the fact that g of x, let's go up, right? So we're going to go up, right? We're going to go up. We know the fact that it's 3x minus 9 over 2, right? So that's what? That's g of h, right? So we know the fact that it's going to be what? So this is going to be the same as 3. So let's just write g of x. Let's just write them here. So we know that g of x is equals to what? To 3x, right? 3x over 9 over 2. Let's just confirm. Yes. Then let me just write f of x here, which is going to be equals to what? F of x is going to be equals to let's go up 2x. So it's going to be 2x squared minus x minus 15, right? So let's just check, double check it. Yes, right? So now we're going to find our what? So we're going to find g at 4. So it's going to be 3. Then it's going to be 4 minus 9 over 5, right? So now when we punch that into the calculator, what we're going to get? We're going to get the fact that YH is basically equals to what? It's equals to 7,5, right? Hope that makes sense, right? When you punch that into the calculator. So now we're going to find for R, we need to substitute x is equals to 4 into f of x, right? So we're looking for YR, which is the same as f of 4, which is going to be equals to 2. Then it's going to be 4 squared minus 4. So minus 4. Then it's going to be minus 15. Punch that into the calculator. We see the fact that what you call this YR, right, is equals to what? It's equals to 13, right? So it's equals to 13. So now remember the fact that we're looking for what? We're looking for the length of what? We're looking for the line HR, right? So we're looking for the length of HR. So we're looking for HR. So we know that RH is 4 is to what? It's 4 is to 7.5. And we know that R is 4 is to what? Is to 13. So using the distance formula, so we know the vector is going to be XH minus XR all squared minus, then it's going to be YH minus YR, right, all squared. Then this is the same as substitute. So this is 4 minus 4 all squared. And this is going to be what? 7.5, right? Minus 13 all squared. So now when you punch this whole thing into the calculator, right? You're going to get that HR is equals to what? Is equals to 11 divided by 2. Which is the same as HR is equals to what? Is equals to 5.5. So it's going to be 5.5, right, units. So that's how you find HR. Now we're going to do 5.1, but we're going to do 5.1.1, right? So 5.5, so we're going to do 5.5.1. Then the first one is that determine the, what you call is determine the what? Write down the domain of H inverse, right? So we know the fact that this, right? We know the following. Basically, we know the following. We know the fact that we have H of X, right? H of X, which is what? Which is a log function, right? Then this changes to what? The H inverse, right? Changes into an exponential function. All right. So we know the following. We know the fact that the domain, we want the domain, sorry. So we're looking for what? We want the domain of, yes, we want the domain of the log, right? Which is the exponential. So meaning the domain here, we have the range, right? So we know the fact that here's the range, right? So the next thing is that we remember the fact that when we were doing the table, right? This table is that the domain and range. So what are we given, right? This is the inverse. This is where the inverse is. Remember the fact that they gave us this is H of X. It's in terms of log, right? And the inverse is this one. They want what? They want the domain of this one. So we know that the domain is what? Is this one, which is going to be X is an element of real numbers. So we know that the domain of H inverse is what is x is an element of real numbers. Hope that makes sense. I just use this. You could also just do it like by knowing the relationship is that always, very important, always the domain of an exponential graph always is going to be the fact that x is an element of real numbers. But just using this table, it was easy for us to determine. Hope that makes sense, Anna. Now they want us to find the range of this one. Remember the fact that the inverse of h of x is the exponential, right? And I'm just gonna write it again. So now going back is that finding the range will be what? Will be this one. This will be your answer, right? So your range for this one is going to be what? It's going to be, so range, it's going to be y is greater than 0. Hope that makes sense, Anna. So now we're going to do 5.6. It says determine the values of k for which the root, and they give us this, right, is equal. So we're looking for equal roots. So what is equal roots, right? So equal roots, right? So equal roots. So I'm just going to write it here. Equal roots. This is from nature of roots, right? So equal roots, right? Equal roots means that the discriminant, which is the triangle, is equals to 0. That's what it means for equal roots. And we know that the triangle is equals to b squared minus 4ac, right? Just remember that. So equal root means this. Then this triangle is basically equals to this formula. Let me just put this inside a triangle, right? So now what we're doing is that we need to calculate for this, then substitute it equated to 0 and solve for what? And solve for k. So that's what we're going to do. So we know the fact that this is equals to b squared minus 4ac. So we need a, b, and c. So where are we going to get it? We see the fact that we're given that 2x squared minus x plus k is equals to 0. This is our a. This imaginary one here, right? So we see that a is equals to 2. Then here there is an imaginary one, right? So this is equals to b. So b is equals to negative 1. And lastly, c is equals to this constant, right? So the one that doesn't have any x is c. So we see the fact that c is equals to k. So now let's substitute, right? So when we substitute, we have the following. So we know the fact that this triangle is equals to negative 1 all squared minus 4. And this is going to be 2. And this is going to be k. Clean it up. So we know the fact that this is going to be 1 minus, and this is going to be 8k, right? So it's going to be 8k. But remember the fact that equal roots means this, so meaning we're going to replace the triangle by 0. So equal roots, we know the fact that 0 is equals to 1 minus 8k. We're looking for k, right? So we're going to take the 8k to the other side. So it's going to be 8k is equals to 1. So therefore k needs to be equals to 1 over 8, right? So that is the value of k, right? So that this becomes equal roots. So now we're going to do 5.7. It says determine the maximum value of g of x minus f of x. So we need to understand what is the maximum value, right? So the maximum value, the first thing that you need to do is that you need to find the simplest way, right? Is that you need to find the first derivative, right, equated to 0. So to finding the maximum value, maybe let's make a note, right? Finding, let me just do this. Let me just move this here, cut it. Let's move it here because I want everything to be in one page. So go back. So finding the maximum value. So finding the maximum value. So first one is that we need to find what the derivative, right? So we need to find the first derivative of whatever we given, right? So find the first derivative, of what we given, given. In our case is what? In our case is this, right? Find the first derivative of that. Then by finding, so by finding the first derivative, we are solving. So find the first derivative and it's equals to 0, right? We are solving what? We're solving for x. So we're solving for x, right? So that's what we're doing. Then what we're going to do is that we're going to substitute the x back into the situation, right? So we're going to substitute x back into the situation. So meaning to make it easy so that there is like order you guys can follow, is that in this instant, let h of x equals to what? To g of x minus f of x, which is the situation, right? So we're looking for what? We're looking for h prime of x is equals to 0. So that's the first thing. And by looking for this, we're solving for x. Hope that makes sense, right? Yes. Then the second part is that we're going to substitute what? The x value that we got, right? Got into h of x. So maybe let's say that the x value, we're gonna call it x1, right? So let's say we got, for example, e.g., right? Let's say, for example, we got our x as maybe x1, right? So what are we solving? We're solving when h is at x1. Hope that makes sense. And this is basically our what? This is going to be our maximum value. So that's how you would calculate the maximum value, right? So this is how you would do it. So let me just put this inside a block. Ooh, okay, cool. Yes. I wanted to fix this mix. Oh, go back. Okay. Hope that makes sense, right? So now let's apply everything. We know the fact that, as we said let. So number one is let h of x equals to g of x, right? G of x minus f of x. So we know that g of x, right? So we know that g of x is equals to what? Is equals to, so it's 3x minus 9 over 2. And we know that f of x is equals to what? To 2x squared, right? Minus x, then minus 15. We know that, right? So let's substitute. So we know the fact that h of x, right, is equals to what? Is equals to 3x minus 9 over 2, right? Then minus, open bracket, because we're dealing with the negative, then substitute f of x, which is going to be 2x squared minus x minus 15, right? So let's clean this up. We know that h of x now is equals to what? Is equals to 3x minus 9 over 2. Then distribute the negative, it's minus 2x squared. Then it's going to be plus x and plus 15. Group like terms. So we know the fact that this, let me just think. We know the fact that this and this are together, right? Then finally, we know that this and this are together. So let's clean that up, right? So we're going to take the negative 2x at the front, so it's going to be h of x is equals to negative 2x squared, right? So when you say 3 plus 1 is going to give you plus 4x, right? Then when you say 9 over 2, so when you say 9 over 2, so when you say a fraction and you say 9 over 2, negative 9 over 2, very important, negative 9 over 2, right? Negative 9 over 2 plus 15, so it's going to be plus 15. We're going to get what? We're going to get plus 21 over 2, right? So that's h of x. But remember the fact that we need to look what? We need to look for h of x, h prime of x is equals to 0. So now we need to find the first derivative, right? So the first derivative is equals to negative 2 multiplied by 2. X is going to be 2 minus 1. I'm differentiating, right? Then this is going to be plus, then it's going to be 4 multiplied by 1. Then it's going to be x, 1 minus 1. And the constant is going to be 0, right? This is using the rules. Hope that makes sense, Anne. This is using the rules. And maybe let me just put the rule here. It says if you have y is equals to what? To ax to the power n, then finding the first derivative is basically equals to what? To a multiplied by n, right? X n minus 1. So this is the rule that I'm using. Go back. So this is the rule that I'm using. Hope that makes sense, right? So that's the rule that I applied. So now let's clean this up. We know the fact that h of x prime is equals to what? It's going to be negative 4x. Then this one's going to be what? It's going to be plus 4, right? So we know the fact that we need to equate this by 0, right? To solve for x. So it's going to be what? It's going to be 0 is equals to negative 4x plus 4. Take the 4 to the negative 4x to the other side. So it's going to be 4x is equals to 4. So therefore, x is equals to what? Is equals to 1. Right? So we know that x is equals to 1, but remember the fact that this is what we're gonna get. This is like x1, right? So now substitute x is equals to 1 into h of x to get the maximum value. Right? So this is going to be the same as what? This is going to be h of 1 is equals to what? Is equals to, so let me just check. This is going to be negative 2. Then it's going to be 1 all squared plus 4, 1 plus 21 divided by 2, right? So we're going to have that. So now with that said is that we're going to basically punch that into the calculator. We see the fact that h at 1 is basically equals to what? Is equals to 12 and a half. So it's going to be 12 divided by, it's going to be 12 and a half. Right? It's going to be 12 and a half units. So therefore, basically the maximum value here is basically equals to 12 and a half units. Hope that makes sense, right? So that's how you would basically answer this question. So now we're going to do question 6. It says f of x is equals to 3 to the power x. Determine the equation of f inverse in the form of this. So we need to find the f inverse for this. So we know the fact that we have f of x, right? So let me zoom it in. It's equals to 3 to the power x. We need to find the first inverse. So the first thing is that we need to write f of x in terms of y. So it's going to be y is equals to 3 to the power x. Then what we're going to do is that we're going to swap our x and y. So let's do that. So it's going to be x is equals to what? Is equals to 3 to the power y. Then now we're going to make y the subject. So it's the same as y is equals to. Then it's going to be log. The exponential becomes a log. Then our base here becomes the base here. So it's going to be 3. Then it's going to be x. So this x here comes this side. Hope that makes sense. So that's how you would find what you call this. So therefore, sorry. So therefore, our f inverse is basically equals to log 3x. Hope that makes sense, Anna. So the second one says the fact that sketch the graph f and f inverse and indicate all the intercept. Remember the fact that when we were doing the previous question, especially when we were doing this 2 is what matters. So I'm going to copy and paste this 2 because we're going to use it again, right? So I'm going to say duplicate, then cut it. Right, we're going to go up. So I'm just going to do this and paste this information again, right? Okay, so this, I'm going to delete it. Then we know the fact that, obviously, let me just delete this one. We delete this one. Now, let's match it up. We know the fact that f of x, right, our log. So we're going to look at the exponential. We know the fact that our exponential is 3, meaning 3 is greater than 1, right? And we see the fact that 1, a is always positive. So we saw the fact that a is positive. So this is what we have, right? So the two functions that we're going to have to sketch is this 2. So let's do this. It's going to be this 2. Do you see? These are the two functions that we're going to sketch. This is going to be for f of x and this is going to be for f inverse, right? Then in our case is that we need to have our x-intercept. So our x-intercept, we know that f of x is going to have a y-intercept and our f inverse is going to have the x-intercept, right? So now let's sketch that, and I'm going to sketch it with different colors so that you guys can see. So this is going to be the Cartesian, right? Then f of x, we're going to make it green, right? So f of x is going to go, sorry. So we're going to say it's going to have its y-intercept here, right? So it's going to go like this, right? So let me just fix this. Yes, right? So that is going to be what? Our ff. This is going to be our f of x. Let's go back. This is going to be our f of x, right? It's going to be our f of x, right? Then our f inverse, remember the fact that this point here is 1, right? Because that is the what? That is the y-intercept. Hope that makes sense, right? Then now our f inverse is going to be this one, right? It's going to be this one, right? So let's make it another color. We'll make it blue. So we know the fact that it needs to cut through here, right? So when it cuts through there, it's going to be like this. Yes. So this is going to be our f inverse, right? So this is going to be our f inverse, right? And we know the fact that this point is 1. And that's how you would sketch this graph. Hope that makes sense, Anne. So now we're going to do 6.3. It says, write the equation of the line of symmetry between the two graphs. So the line of symmetry is a line where if you cut the graph at that line, right, it's a mirror image of the other one. We see that that line is this line, right? So it's this line. So this line, maybe I'm just going to do it in dotted line so that you guys can have it. And I'm going to just call it the line of symmetry, right? So we're going to make it in red, right? So let's sort it out. Yes, this is the line of symmetry. Let me just go back to solid, right? So this is the line of symmetry, right? So this is the line of symmetry, right? So this is the line of symmetry. Let's hope I can spell it right. And always the line of symmetry is y is equals to x. So just a keynote, right, is that the line of symmetry, sometimes when asking for the inverse, they say the fact that the line that reflects on this line. So when they say write the equation of the line that reflects on this means finding the inverse. Hope that makes sense, right? Just wanted to just add that. So to answer this question, we know the fact that this is going to be y is equals to x because that's the line of symmetry. Hope that makes sense, Anna. So now we're going to do 6.4, right? It says for which value of x will f of x multiplied by g or by f inverse, sorry, is less than and equals to 0. right? So now we need to understand what's going on. We're looking for when f of x multiplied by f inverse it gets a negative. So when can we get it? If f of x is positive, right, we know the fact that this one needs to be negative, because when you multiply this 2, you're going to get what? You're going to get a negative, right? Or this one is negative and this one is positive, right? Because when you multiply the 2, you're going to get a negative. So now when can we get what is negative and what is positive? For both of them, right? For both of them, is that the negative, we're looking at the y-axis, right? So we're going to highlight. So what we're going to do is that we're going to highlight the negative part of the graph as being red and the positive part as being green, right? Then we're gonna evaluate it where we need to, in each portion we need to have a red and a green. So now starting with f of x, do you see the fact that f of x is above the y-axis, the positive y-axis, meaning anything that is above this line, everything here is going to be green, right? Because that's positive y-axis. So meaning also this one above it is positive. Hope that makes sense, right? Then the negative is going to be this one, right? For the inverse. Hope I'm making sense, right? So now we need what? Remember the fact that the question says the fact that the values of x. So we need the value of x. So go back. So what is the value? The values of x, right? So the values of x is, first is the x-intercept of f of x and f inverse. And also it's going to be the asymptote. So we see the fact that we have the asymptote. So I'm going to just do it in dotted line, right? We have the asymptote here, which is going to be x is equals to 0. So this is going to be the first one, right? And the x-intercept, only f inverse has the x-intercept. So this one, right? So let's just sort it out. Right? So back to solid, right? So we know the fact that, let me just delete this one because we don't need it. Yes, right? So back to solid, right? So we know the fact that this is going to be the same portion, the first portion, and this is from negative infinity till what? Till 0, right? Then from 0 till 1, this is going to be portion 2, and till 1 till positive infinity is going to be portion 3, right? So what are we looking for? We're looking for each portion. We're looking for when we see a red and a green. If we don't see that, then that's not part of our solution. So for the first portion, right, is that we ask ourselves, right, do we see a red and a green? No. So this is not part of the solution. The second portion is that, do you see from here to here? We see the fact that we have green here and we have red. So this part is part of the solution. And this one, they both green. So this is not part of the solution. So your answer is between these two, right? But you see the fact that here they said equals to, meaning this is going to get a square bracket, but this here is going to get a curve because of this one is an asymptote, right? So our answer is going to be what? It's going to be x. So your answer is going to be, since we have this equal sign, so your answer is going to be x is an element, curve bracket, because there is the asymptote, till 1 and square, since it is the x-intercept. Hope that makes sense, right? Okay, so now we're going to do 6.5, right? So with 6.5, it says write down the range of h of x is equals to this, right? So what I'm going to do is that I'm going to give you like a formula that you need to use for finding the range of an exponential, right? So finding the range of an exponential, right, is going to be what? It's going to be y, right? So it needs two things. So basically it needs two things, is that if a is greater than 0, right, then therefore your range, right, your range is going to be what? So let me just do this. Your range is going to be y is greater than q, right? Then if your a, so let's do this, If your A is less than 0, then your Y is going to be basically less than Q, right? So it's dependent on what? It's dependent on your A and your Q. So that's what you need, right? So let me just pull this up. Yes, right? And put this inside, underline this, put this inside a box, right? So now from our question is that we need to basically determine what? We need to determine our A and Q. So we see the fact that A in our question, so go back. We see that A in our question is equals to what? Is equals to +1. This is B. This, the number, since there is nothing, it's going to be equals to +1 because it's going to be 1 multiplied by this. And since it's 1, we don't write it, right? So we see the fact that this is going to be 1, right? And we see that 1 is greater than what? It's greater than 0. So meaning this is going to be our option, right? Hope that makes sense. Then we see the fact that Q is this one, right? So Q is equals to -4. So from there, we know that Y is greater than -4. And that's going to be your final answer for this question. So now we're going to do 6.6, right? It says write down the equation of G. If the equation G is an image of F, right? After it has been translated, meaning 2 units to the right, 2 units to the right. Let me just underline this. To the right, right? Do you see to the right means what? It means the fact that, okay, what the hell? Okay, to the right means the following. Is that the graph is going to go this direction. But if it's going this direction, that means the fact that this is negative. Remember the fact that P is always opposite of when you're dealing with left or right, right? If they're saying right is normally positive side, but it's going to be the opposite side. So this is going to be basically -2, right? Then they tell us the fact that it reflects on the x-axis, right? X affects what? Affects y, right? So we're looking for minus f of x. Hope that makes sense, right? So now let's write G. So G of x is basically equals to minus f, right? But inside is that, remember the fact that this right affects x, right? So this is going to be the same as x minus 2, right? So now G of x is equals to, let's find f of x. Let's go up. Remember the fact that our f of x is equals to what? Our f of x, where is it? Our f of x is 3x, right? So it's 3x. So we know the fact that it's going to be 3 to the power x, right? So now is that it's going to be minus, right? Minus open bracket. I'm going to say 3 to the power. Now, wherever I see x, I'm going to put this, right? So it's going to be x minus 2, right? So this is going to be the same as G of x. Distribute the negative is equals to minus 3. Then it's going to be x minus 2. So that's going to be your G of x. Hope that makes sense, Anna. So now we're going to do finance, right? So the first one, it says, question 7, right? A business buys a machine that cost 112,000. The value of the machine depreciates at 9% per annum according to the diminishing balance method. Then they say determine the scrap value of the machine at the end of 5 years. So the scrap value is that we're finding how much the machine has depreciated. So using the depreciation method. So they tell us the fact that what type of method is used is the diminishing, right? So since we're using the diminishing balance, so for the diminishing balance method, this is the formula, which is going to be A is equals to P. That's going to be 1 minus I to the power N, right? So let's put this inside a block. So we need the following, right? We're looking for A. This is the scrap value. The scrap value is going to be A. So we need P, we need I, and we need N. So we see the fact that P is going to be how much the machine cost, which is going to be 120,000, right? I is going to be the interest rate, which is 9%. But we need to convert it. So it's going to be 9 divided by 100, which is the same as 0.09. Then lastly, we need the amount of years, which is they tell us at the end of 5 years. So we see the fact that N is equals to 5. So let's substitute. So we see the fact that A is equals to P. That's going to be 1 minus I to the power N. Substitute. A is equals to 120,000. That's going to be 1 minus 0.09. Then this is to the power what? To the power 5. Punch that into the calculator. You're going to get A as being equals to what? This is going to be 74, right? 74,883,86. So that's how you would calculate the scrap value. Then we're going to do 7.1.2. It says after 5 years, the machine needs to be replaced, right? It needs to be replaced. During the time, the inflation remained constant at being 7% per annum. Then they say calculate the cost of the new machine. So the cost of the new machine, we're going to be use compound interest, right? We're going to be using this formula. So for the new machine, new machine, right, is that we're going to use A is equals to P. Then it's going to be 1 plus I to the power N, right? So let's put this to calculate the new machine. So we need A, right? So the new machine is going to be A. Then we need P, we need I, and N. So we see the fact that P is going to be what? It's going to be the original price, right? Remember that the original price was 120. So we want to see how much it grown, like from the original price. So it's going to be, this is going to be the original price, which is going to be P, right? So it's going to be 120,000. And then I, they tell us the fact that the inflation, right? The inflated rate is 7%. So we know the fact that that's 7%. Which is the same as 7 divided by 100, which is equals to 0.07. Then after the end of 5 years, so it's going to be N is equals to 5 years. So let's substitute. So the new cost after 5 years, after it being inflated, right? Inflation affecting it. So it's going to be A is equals to 120,000, right? Then it's going to be 1 plus 0.07. Then it's going to be to the power 5. Punch that to the calculator, right? We see the fact that A is equals to what? It's going to be equals to 168,306,21. So that is the cost of a new machine when it's inflated after 5 years. Hope that makes sense, Anna. So 7.1.3, it says the business estimate that it will need approximately 90,000 by the end of 5 years, right? A sinking fund for approximately 90,000 into which equal monthly installments must be paid, right? Is set up, right? It's set up. Then they tell us the fact that the interest on the fund, on the sinking fund, is 0.5% per annum compounded monthly, right? And they tell us the fact that the first payment will be made immediately, right? And the last payment will be made at the end of the period of 5 years. Then they say the fact that calculate the value of the monthly payments into the sinking fund. So first what I'm going to do is that I'm going to calculate, was it like, is the approximation true or not, right? Whether it's true or not, then we're going to set up the sinking fund to calculate the monthly installments, right? So now, before we do that, let's highlight all the important information, right? We see the fact that the approximation is 90. 90,000, which that's going to be our future value. That's going to be our FS. Then we know the fact that that ends within 5 years. So we know the fact that it's going to be 5 years. Then they tell us, yes, the sinking fund. So they tell us that the interest rate is 8.5%, and that is compound monthly. So that's very important. Another important statement, they said the first payment, right, is made immediately. This immediately means something, right? Meaning we need to add our n plus 1, right? And they tell us that the last thingy is after 5 years, right? So the first thing is that we need to check the fact that is their approximation true or not, right? So the sinking fund value. So let's check. So step number 1, we're going to check whether the sinking fund approximation is true or not, is true or not. So to check that, right, so to calculate the sinking fund, so the sinking fund is equals to what? Is equals to the new machine cost. So it's going to be equals to the new machine cost minus what? Minus the minus the scrap value. So minus the scrap value. So we know the fact that the cost is going to be this one. So let me just take it. It's going to be this one, cut, and we're going to paste it here. So minus the scrap value, which is going to be this one, duplicate it, cut it. So this is going to be minus, paste it here. Yes. Okay, good. So let me just erase this, move it properly. So minus this, then punch that into the calculator. You're going to find the fact that it's going to be equals to what? It's going to be equals to 93,000, right? 422,35. So the approximation, this and 90 is more or less close to each other, right? So now with that, we know the fact that it's correct. The approximation is right? So now calculating the monthly installment, the monthly installment, right? Using the 90,000. You don't use this one, you use the 90,000. Hope that makes sense, right? Because that's what they used, right? So we know the fact that to calculate the monthly installment is that the sinking fund, we use this formula, the F, right, is equals to what? The future value. So it's going to be X, then it's going to be 1 plus I, right? Then it's going to be N. Remember the fact that it's going to be N multiplied by M. So just I is divided by M. It's going to be N multiplied by M plus 1. This plus 1 is because of the immediate payment, right? The plus 1 is for the immediate payment, right? And this is going to be what? This is going to be minus 1, close square bracket. Right? And this is going to be what? This is going to be I divided by M. Right? So now let's put what we have. So we know the fact that we have the following. We have the future, which is going to be 90,000. Then we have our interest rate. So we have our interest, and our interest is going to be equals to what? It's 8.5, right? So it's going to be 8.5 0.5%, which is the same as 8,5 divided by 100, which is going to be 0,085, right? Then we have what? We have our n. They say after the period of how many years? 5 years, so it's going to be 5. Then it's compounded monthly, which is going to be m. It's going to be 12 because that's monthly. And lastly, yes, then we have everything, right? And we're looking for x. So now let's substitute. So when we substitute, it's going to be 90,000 is equals to what? Is equals to x. Then it's going to be 1 plus, then that's going to be 0,085 divided by what? Divided by 12. And this is going to be 5 multiplied by what? Multiplied by 12 plus 1. Then this is going to be minus 1. Then square bracket. That whole thing is going to be divided by what? By 0,085 divided by 12. Hope that makes sense, right? So now we want x alone, right? So since we want x alone, is that I'm going to take this and multiply it this side, right? So it's going to be 90,000. So it's going to be 90,000, right? Since it's dividing, so it's going to multiply this side. So it's going to be 0,085 divided by 12 is equals to x square bracket. So it's going to be 1 plus 0,085 divided by 12. Then this is going to be 5. So when you say 5, right, multiply by what? Multiply by 12, then plus 1. That's going to be what? That's going to be equals to 61. Then this is going to be minus 1 and square bracket. So now we want x alone, right? So I'm going to take this whole square bracket and divide it this side. So this is going to be 90,000 multiplied by 0,085 divided by 12, right? And this whole thing is going to be divided by what? Divided by this. I'm just going to take it here, duplicate it, cut it. So I'm going to paste it here. That's the square bracket, yes, right? And this is going to be equals to, and this is going to be equals to, ooh, and this is going to be equals to x. Then punch this into the calculator, right? So when you punch this into the calculator, we find that x is basically equals to what? To 1,000, right? 1,184,68. So this is going to be the monthly installments. So now we're going to do 7.2. It says Kasalo receives an amount of 900,000 upon her retirement, right? She invests the amount immediately at an interest of 10%, right, per annum, right, and compounded monthly, right? So they say the fact that she needs an amount of 18,000 per month to maintain her current lifestyle and plans to withdraw the first amount at the end of the month, right? Then they say the fact that for how many months will she be able to live off the investment? So what are we going to do if you have money, right, and you get money and you want to live out of it? You use the present formula to basically calculate how much you can live out of it. So the formula that we're going to use is the P1. So it's going to be P is equals to what? Is equals to X, right? And this is going to be 1 minus, this is going to be 1 plus I divided by what? Divided by M. Then this is going to be negative N multiplied by M. Close square bracket. And this whole thing is going to be divided by what? Divided by I divided by M. Hope that makes sense. This is the formula that you're going to use. So if you're calculating someone getting the retirement and they want to know how much they live out of it, this is the formula that you're going to use. Hope that makes sense, right? So from here, we need what? We need to know how much Cassandra can basically live out of this. So to know that is that we need to calculate for the number of months, right? So we're calculating this. Hope that makes sense, right? So with that is that I'm just gonna, with this is that this one, I'm just gonna rewrite it as just n, because that's what we're calculating, right? I'm just gonna rewrite it as being n because that's what we want. Then this and this, we're gonna leave the m there. Okay? So now what do we have? We have P, right? So P is the retirement money. So we know that the retirement money is 900,000. And we know the fact that how much does she need to live off is going to be X, which is going to be what? 18,000 that she needs, right, to live off. Then they tell us that the interest rate. So let's go basically underline. So this is going to be our P. This is going to be our X. This is our percentage. And this is our M, right? So we know the fact that, and we're looking for X. We're looking for N, right? Hope that makes sense. So we know the fact that this is X, then we're looking for I. We know the fact that it's 10.5%, which is the same as 10.5 divided by 100, which is going to be the same as 0.105, right? Then we know the fact that M is equals to what? Is equals to 12. Then lastly, we're looking for N, and N, that's what we're looking for, right? Then the amount of months that she can live out of this 18,000. Hope that makes sense when she invests it. So now taking the formula, it's going to be P is equals to X, right? And this is going to be 1 minus, this is going to be 1 plus I divided by M, and this is going to be negative N. I'm just going to replace this whole thing, right, by N. So let's do this so that it makes sense. So N multiplied by M, I'm just going to replace it by N. Hope that makes sense. Right? So this whole thing is going to be replaced by this. I'm just going to put the negative, right? And this is going to be square bracket. And this whole thing is going to be divided by what? Divided by I divided by M, right? Substitute. So we know the fact that the side is going to be 900,000. It's equals to 18,000, right? And this side is going to be 1 minus, that's going to be 1 plus, then this is going to be 0.105, right? Divided by 12, and this is going to be negative N, right? Then it's going to be square bracket, then this whole thing is going to be divided by the interest, so it's going to be 0.105 divided by 12, right? So now we want N to be the subject, so we're going to take this to the other side, right? So since it's dividing, it's going to multiply. So it's going to be 900,000 multiplied by 105 divided by 12 is equals to 18,000. And then it's going to be the square bracket. It's going to be 1 minus, it's going to be 1 plus, right? 1 plus 0.15 divided by 12. And this is going to be to the power negative N, right? So that's what we're going to have, right? So that's what we're going to have. So now I'm not going to clean it up, right? I'm not going to clean it up yet. So what I'm going to do now is that I'm going to take this and take it to the other side so that we can have this alone, right? So now let's do that. So when we do that, it's going to be 900,000. Then it's going to be multiplied by what? This is going to be multiplied by 105 divided by 12, and this whole thing is going to be divided by 18,000, and this is going to be equals to what? This is going to be equals to 1 minus, and this is going to be 1 plus 0.105 divided by 12, and this is to the power negative N, right? So that's what we're going to have. So what we're going to do is that we're going to punch this into the calculator. So you're going to put a fraction and you're going to say 9,000. So it's going to be 900,000. So it's going to be 1, 2, 3, 4, 5. And that is going to be divided by what? Then multiply, sorry. So that's going to be multiplied. This is going to be multiplied by the fraction, which is going to be 105. So it's going to be 0. So it's going to be 0.105, right? Divided by what? Divided by 12, right? And that whole thing is divided by 18,000. So this is what we're going to get. So remember the fact that this is, I keep on making a mistake, this is 0, this is 0, 0.5, this is 0, 0.5, right? So we're going to have that. So that's going to be 0, 0.5. And when you punch that, you're going to get the fact that's going to be 7 divided by 16, right? And this is going to be equals to 1 minus. Then I'm going to clean this up, right, inside my calculator. So when I do that, it's going to be 1 plus a fraction, which is going to be what? Which is going to be 0.1. So it's going to be 0.105, right, divided by 12. I just want it to be a number. And here, this is the same as having what? This is the same as having 807 divided by what? Divided by 800, right? And this is to the power negative n. Then I'm going to take this one to the other side. So this is going to be 7 divided by 16 minus 1 is going to be equals to what? It's equals to negative. Then this is going to be 807 divided by 800, then to the power negative n, right? So when you do that, you're going to say 7. So you're going to say 7 divided by what? 7 divided by 16, right? Minus what? Minus 1. You're going to get your answer as being negative. So it's going to be negative 9 divided by 16. It's equals to negative. Then this is going to be 807 divided by 800. Then to the power negative n. Then the negatives are going to drop each other. So it's going to be 9 divided by 16. It's equals to 807 divided by 800. And to the power negative n, right? So now with that, now we're going to basically solve for this n. So since this n is a power, we're going to use log. So this is the same as having negative n is equals to log, right? Then our base is going to be this one, right? So our base is going to be this one. This is going to be 807 divided by 800, right? And here we're going to have this. So it's going to be 9 divided by 16, right? So punch this into the calculator. You're going to have what? You're going to say log, but log with the base, right? So log with the base. So you're going to get it as negative. So it's going to be negative n is equals to negative 66,0429, right? Then it continues. But we see the fact that both sides are negative. So therefore, we see the fact that n is basically equals to 66,043, right? So since it's equals to that, is that n, you always round up, right? So therefore, we know the fact that n is basically equals to 67 months. So welcome to calculus. So we're going to do the first question, which is 8.1. It says given f of x is equals to negative 2x squared plus 1. Then the first one, it says 8.1.1, determine f prime from the first principle. So we need to understand what is the first principle. We know that the first principle is f prime of x is equals to the limit when h approaches 0 of f of x plus h minus f of x divided by what? Divided by h. So we're going to put this into a red box. Then that's what we're going to do. So the easiest way is to basically solve the numerator, right? Each component. So we already have what f of x is. So what we're going to do is that we're going to find f of x plus h. Then we're going to do the entire numerator, simplify it, then put it back after simplifying it. So the first thing is that we need to find f of x plus h. And that's going to be equals to what? This is going to be negative 2. Then now, wherever we see x, right? We're going to put what? We're going to put x plus h. So let's do that. So it's going to be x plus h all squared, right? And this is going to be plus 1. So now let's simplify this. So it's going to be negative 2, open bracket. This is going to be x squared plus 2xh. then it's going to be plus h squared, then this is going to be plus 1. Then we're going to distribute the negative 2. So it's going to be negative 2x squared, right? And this is going to be negative 4xh. Then it's going to be negative 2h squared, and this is going to be plus 1. Then we see the fact that we can't simplify any further, so we're going to just leave it like this. Then now what we're going to find, what? We're going to find f of x plus h minus f of x, right? And that's going to be equals to, then we're going to substitute f of x plus h, so it's going to be negative 2x squared minus 4xh minus 2h squared plus 1, right? Minus, then inside the bracket, we're going to substitute f of what? F of x. So this one. You always put it inside the bracket because the negative is going to affect it. So it's going to be negative 2x squared plus 1, close bracket. So now let's clean this up, right? So when we clean this up, we're going to have what? We're going to have negative 2x squared minus 4xh minus 2h squared plus 1. Then we're going to distribute the negative. A negative and a negative is going to give you a positive. So it's going to be plus x plus 2x squared. Then it's going to be negative 1. Then what do we see? We see the fact that this and this are going to cancel out, and this are going to cancel out since it's different signs. So this and this are going to cancel out, and this are going to cancel out. And you know the fact that you're doing the right thing if the original f of x basically does not exist anymore. Then you know the fact that, you know what, I'm doing the right thing. So now what we're going to be left is negative 4, right, xh, then it's going to be minus 2h squared, right? Then what we do is that when we get here, we always take out h, just one h as a common factor. The reason why is that we want to get rid of this h. The whole point of doing this is to get rid of this, because of if you substitute 0 here, it's going to give you undefined. So our whole point is to get rid of this h. So it's going to be what? So when we take out just that one h out, it's going to be h. So we're going to be left with negative 4x. Then this is going to be what? It's going to be minus 2h. Then close it, right? So this is your numerator now. So updating it now, writing it using the first principle, is going to be what? This is going to be f prime of x is equals to the limit when h approaches 0. Then this is going to be f of x plus h, right, minus f of x. And this whole thing is divided by what? Is divided by h, right? Then we're gonna put this is our numerator. Remember the fact that this and this, basically that's our numerator. So we're gonna write the limit. Then it's gonna be h when h approaches 0. So it's gonna be h open bracket 4x minus 2h, right? And this whole thing is gonna be divided by h. Then we see the fact that this h and this h are gonna cancel out, which is what we want. So it's going to be equals to the limit when h approaches 0, and what we're going to be left with, so they're going to cancel out. So it's going to be negative 4x minus 2h, right? Then now, since we got rid of the h, this h, is that we can substitute. So when we substitute, do you see the fact that when h approaches 0, so we're going to substitute 0 wherever we see h, right? The minute you substitute 0 is that you don't need to write this limit anymore. So this is going to be what? This is going to be negative 4x minus 2 open bracket 0. So therefore, this is going to be negative 4x. So using the first principle, this is going to be your final answer. Hope that makes sense, Anna. So now we're going to do 8.1.2. It says, hence calculate the gradient of the tangent to f at x is equals to negative 1 over 2, right? So basically how to find the gradient of a tangent, right? When you're given a function, this is the equation, right? And I'm going to put inside a box, is that you need to find the first derivative, right, at that point. So I'm going to call it at x c, which is the point of contact, right? And this is the point of contact that they give us. Whatever x is equals to, that is always going to be the point of contact, right? And that is going to be equals to what? That is going to be equals to your gradient, right? So that is how this is, right? So what do we need, right? We need f of x. So we know the fact that f of x, in our case, if we go up, right, it's going to be equals to negative 2. So it's going to be negative 2x squared, right? So negative 2x squared plus 1. So this is going to be plus 1, right? So we have that, right? But remember the fact that in the question they said hence, right? So we already know the fact that we have solved the first derivative. So we have solved the first derivative, which the first derivative is equals to this. So we already know from hence, not from hence, from 8.1.1, because that's the hence, right? We already know the fact that what? We already know that the f prime of x is basically equals to negative 4x, right? So, but remember the fact that we're looking for what? We're looking for, so, and we given that xc is equals to this negative a half. Hope that makes sense, right? So basically, we're looking for an f prime of xc, which is the same as what? Which is in our case, so we know the fact that f prime of 1 over 2. That's what we're looking for, right? So we already know that this is equals to negative 4. So now wherever we see, this is minus, right? Minus a half. So wherever we see x, we're going to put negative a half from here. Basically, this is what I want to do from here, right? So it's going to be minus a half, right? And when you punch this into the calculator, right? So when you punch this into the calculator, you're going to find the fact that this is going to be equals to positive 2. So therefore, I don't even need to go. So therefore, the gradient is equals to positive 2. And that's your final answer to this question. So now we're going to do 8.2. It says determine the derivative of f of x, right? So we're going to use this rule, right? So this is the rule. This is the only rule that you need to know. Okay, 2 of them. It's the only rules that you need to know. So rules. So we have the first one, right? So let me just underline this, right? We have the first one. If we have y is equals to what? Is equals to ax n, right? Therefore, y prime, which is the derivative, right, is going to be equals to a multiplied by n, so the power, right? Then it's going to be x is going to be n minus 1, right? Then the second one is dealing with the constant. So when y is equals to just a, then y prime is equals to 0. These are the only rules. The rest of them, don't even stress yourself. This is the only rules that you need to know, right? So now with that said, is that now let's deal with f of x. So they gave us the fact that f of x, right, is equals to what? Is equals to 3 root, then it's going to be x all squared, right, plus 1 divided by 4, x to the power 4, right? So now finding the derivative, right, using the rules, it's very important that we never deal with the square root and we never deal with a negative, a fraction, basically, right? So our goal is to write it in this form, right? Always write it in this form so we can apply either of the two rules. So now let's get rid of the root, right? And let's get rid of this fraction. So we know the following, that f of x is going to be equals to x, then this is going to be 2 divided by 3, right? So it's going to be 2 divided by 3, or let me just do this so that you guys can see. We know the fact that it's going to be x all squared, then a cube root, right, is the same as 1 divided by 3, right? So we can change this into this. Hope that makes sense, right? Then plus here is going to be what? We're going to basically take the x to the power 4 on top. So it's going to be x to the power negative 4, right? So if you move this on top, if it's under a denominator and we move it on top, it becomes negative because of this is positive. Hope that makes sense. And this is going to be divided by 4, right? So now let's clean up this one. So it's going to be f of x is equals to multiply the exponent. So it's going to be x, then it's going to be 2 multiplied by 1 over 3. It's going to be 2 over 3, right? And this is going to be plus, this is going to be what? This is the same as 1 over 4, right, x to the power negative 4. I'm writing it, taking out the number because I'm going to use it, right? So now I'm going to apply this rule, right? So the minute I start applying this rule, my f of x no longer becomes f of x, but it becomes f prime, right? So it's going to be f prime of x is equals to, so we know the fact that here there's like a 1, a positive 1, so it's going to be 1 multiplied by what? Multiplied by 2 over 3, because that's what the rule says. You take the power, you multiply it with the number in front, then it's going to be x, then it's going to be 2 over 3, then you subtract it by 1, so it's going to be minus 1, and this is going to be plus 1 over 4. Take the number, the power in front, so it's going to be multiplied by negative 4, then it's going to be x, it's going to be negative 4 minus 1. So now let's clean that up, right? So it's going to be f prime of x now is going to be equals to, this is going to be 2 over 3, right? It's going to be x, and that's going to be what? That is going to be, when you say 2 over 3 minus 1, it's going to give you what? It's going to give you negative what? Negative 1 over 3. Right? Then this one is going to be negative 1 over 4 multiplied by negative 4. It's going to give you what? It's going to give you a negative 1, right? Then this is going to be x to the power negative 5, right? So now let's clean it up further by making this exponent, both of them what? Both of them are positive, right? So it's going to be f prime of x is equals to 2 over 3. Then it's going to be x to the power 1 over 3. Then this is going to be minus, you can just ignore it. So it's going to be minus 1 divided by x to the power 5, right? So that is the final answer for this. So now we're going to do 8.3. It says, given that h of x is equals to ax squared, and they tell us the fact that a is greater than 0, meaning it's positive, meaning our a needs to be positive. They say determine the value of a if it's given the fact that the h inverse of this one is equals to, when you substitute 8, is equals to the h prime of this one when it's equals to 4. So the first thing that we need to do is that we need to find the h inverse and we need to find h prime of x. So let's start with h inverse, right? So number one, finding h inverse of x, right? So let's do that. So when we find the h inverse of x, we know the fact that we have h of x is equals to ax squared, right? Then what we're going to do is that we're going to write h of x in terms of y. So we can swap them. So it's going to be y is equals to ax squared, right? Swap them. So it's going to be h, so swap. So swap y and x. So when we swap them, this is going to be x is equals to what? Is equals to a y squared. Make y the subject. So now I'm going to divide a to the other side so that y can be alone, because we want to make it the subject. So this is the same as x divided by a is equals to y squared. Square root both sides. So it's going to be the square root of x divided by a, right, is equals to y, right? So that's your equation for what? For h of x. So this is going to be, therefore, our h inverse of x is equals to what? It's equals to the square root of x divided by a. Hope that makes sense, right? So that's what we have as being the h inverse. But they told us the fact that the h inverse at 8 is equals to what? Is equals to this one. So let's find h of 8. So let's finding h of 8. So finding and okay, wait. So let's find h inverse of 8 is equals to, so we know the fact that this is the square root, right, of 8 divided by a, right? So that is what we have as being h of 8. Hope that makes sense. So now we have that. Now we need to find h of what? H of, or what you guys, h prime at 4, right? So that's what we're going to be finding. So finding, first finding, number 2, finding h prime at 4. I think here, let's say, yes, because that makes sense, because that's what we're finding, right? So let me just move this a little bit just here. That's good. So now we know the fact that h of x, right, is equals to ax to the power 2, right? So that's what we have. So finding h prime, so it's going to be the first derivative. Then we're going to apply the rule. So it's going to be a, take the power in front, multiply by 2. Then it's going to be x, then it's going to be 2 minus 1, right? So it's going to be h prime of x is equals to what? Is equals to 2ax, right? So that's what we have. But remember the fact that we're looking for h prime at 4. So wherever we see x, we're going to substitute by 4. So it's going to be 2a, then this is going to be 4, right? So therefore, this is going to give me what? This is going to give me h prime at 4 is equals to what? Is equals to 8a. Hope that makes sense, right? So we need to solve for a, and they tell us the fact that these two are equals to each other. So now finding a, right? We know the fact that this is number 3. Let's move it again. Right? So we know finding a, we know the fact that what? H prime at negative, what you call H inverse. So we know the fact that H inverse at 8 is equals to H prime at 4. Hope that makes sense, right? So we already know what this one is the square root. So that is the square root of 8 divided by a, right? And this one is equals to 8a, right? So we know that too, right? So now with that said is that let's clean it up, right? We want to get rid of the square root. So we're going to square both sides. So this is going to be 8 divided by a all squared, right? And this is going to be 8a all squared, right? So that's what we're going to have. So here the square root and the square is going to cancel out. So it's going to be 8a. And this side we're going to have what? We're going to have 64a squared, right? So that's what we're going to have. So now what we're going to do is that we're going to cross multiply. This is the same as divided by 1, right? So this is the same as divided by 1. When we cross multiply, we're going to say 8 multiplied by 1 is going to give me 8. And the other side is going to be a multiplied by, so it's going to be a multiplied by 64a squared, right? So 8 is going to be equals to what? To 64a cubed, right? So now we're going to take the 64 to the other side because we want a to be alone. So this is going to be the same as 8 divided by 64, right? Is equals to a cubed, right? So 1 divided by 8 divided by 64 is the same as 1 divided by 8 is equals to a cubed, right? So you're going to cube root both sides so we can get rid of the cube. So it's going to be the cube root of 1 over 8, right, is equals to cube root of a cube. The cube root and the cube are going to basically cancel out. So this side, we know the fact that the cube root of 1 over 8, when you punch that into the calculator, you're going to get 1 over 2 is equals to a. So therefore, your a is basically equals to a half. And that's how you would solve this question. So now we're going to do question 9, right? So let's read question 9. It says the graph of the function and its f of x is equals to negative 2x cubed plus ax squared plus bx plus c is sketched below, right? And they tell us that the following properties of f are given. So we're given that point A, which we see here. So what do we see with point A, right? They tell us the fact that point A is the stationary point. Stationary point means turning point, right? It's another name for turning point. But we see on our diagram is that not only is it the turning point, but it's also what? It's also the x-intercept, right? So we see the fact that it's the turning point. So this is the turning point. So this is the turning point and the what? And the x-intercept. So this coordinate has two properties, turning point and x-intercept. Then we go, they tell us the fact that point B is the x-intercept, right? And they tell us the fact that point P is the point of inflation. So we know the fact that this is the point of inflation, right? Then when we continue, they tell us the point C is the turning point. So we see the fact that this is the turning point, and they tell us the fact that D is the y-intercept. So that's what we have, right? So now with the first question, right, let me move to black. The first question, they tell us the fact that we need to show that A is equals to positive 12, B is equals to negative 18, and C is equals to 8, right? So where's A? This is A, B, and C. So how can we do that? We're going to use this formula. So we're going to use this formula. This formula is when you are given a turning point, right? So this formula you use when you're given the turning point, right, as being the turning point and the x-intercept, which is repeated root, right? So repeated root formula. So this is going to be repeated root, right, formula. So I'm going to say repeated root formula. Yes, right? So when you have repeated root formula, and what is repeated root, right, is that, okay, cool. Repeated root, right? Repeated root means the following, means that your turning point, your turning point, so one of your turning point, right? So it means that let's do this, means that one of your turning point right, one of your turning point and one of your x-intercepts is the same coordinate. Yes, all right. So with that is that you're going to use this formula, which is going to be what? Which is going to be y is equals to the repeated root, which is going to be, so it's going to be a, right? In our case, when we say a, we mean the coefficient of x cubed, right? So I'm going to just write it. What does it mean, right? So it's going to be a, and then it's going to be x minus x1, right? All squared. Then it's going to be x minus x2, right? So in this case, a is the coefficient of x cubed. That is what a is, right? So this question, they just decided to name, this is normally in the coefficient, this is normally b, and this is c, and this is d. But here is that since they gave you the a, they just named a, b, and c. It's just alphabets, right? But you just need to know what it means, right? So now with that, that is how you would basically find your a, b, and c. So we know that. So now let me put this inside a box, and now let's apply what we have, right? And very important, right, is that your xa, right? Do you see the fact that x1 and x2, right? The one with the repeated needs to come here, and we always substitute the opposite sign. When with the one with this, you always substitute the opposite sign. Hope that makes sense, right? So we're going to do what? We're going to solve the question. So we need what? So we know the fact that f of x can be written in terms of a, then it's going to be x minus x1 all squared, then it's going to be x minus x2, close it, right? Then we need a and x1 and x2. So we see the fact that a is equals to, from your f of x is equals to -2. So we know the fact that that is going to be equals to -2. Then we see the fact that x1, the one with the repeated root, meaning this one is the one with the repeated root because it has the square, right? So we know the fact that this is going to be equals to what? Since here it's 1, meaning x1 here is going to be equals to -1. Then x2, right, is going to be equals to, since here in the graph is +4, here is going to be equals to -4. So that's what we're substituting. So now let's substitute. So that's going to be -2, open bracket, is going to be x minus 1, right? That's the one with the repeated root, all squared. And this is going to be what? This is going to be x minus 4, right? So now what we're going to do is that we're going to expand this, right? So we're going to expand this. So when we expand it, we're going to have the following. So we're going to have, so when we expand it, we're going to have the following. So we're going to have -2, then open bracket, we're going to have x squared minus what? Minus 2x, right? Plus 1, then close bracket is going to be x minus 4, right? Then now what we're going to do is that we're going to basically distribute this here. So we're going to expand this also. So we're going to have what? So when we expand that, we're going to have that -2, open bracket, now we're going to have x cubed, right? So we're going to have x cubed minus 4x squared, then it's going to be minus 2x squared, then it's going to be plus what? Plus 8x, right? Plus x minus 4. So now let's clean this up. So when we clean this up, it's going to be -2, open bracket, now we're going to have x cubed, right? So grouping like terms, it's going to be minus 6x squared, then it's going to be plus 9x, right? Then it's going to be minus 4. Then now we're going to distribute the -2. So it's going to be equals to what? This is going to be equals to -2x cubed, right? And this is going to be plus 12x squared. Then it's going to be minus 18x. Then lastly, it's going to be plus 8, right? So we see the fact that now, therefore, we see that f of x is basically -2x squared plus 12x squared cubed, then it's going to be minus 18x plus 8, right? Remember the fact that we were already given this. So this is going to be your A, this is going to be your B, and this is going to be your C. So this is your A, and this is your B, and lastly, this is your C, right? So therefore, we see that A is equals to 12, right? B is equals to -18, and lastly, C is equals to 8. And that's exactly what they said we should prove. Hope that makes sense on how to solve this question. So now we're going to do 9.2. It says, Kusa states, right? So the student states that the tangent to a curve, right, of f can be drawn, right, through the point C and D. So it's that we have a tangent, and obviously a tangent happens on a curve. So meaning that tangent line, right, needs to go, we basically trying to prove the student statement, the fact that that line, right, the curve, the tangent line can go through the point C and D, right? So we need to validate the statement by using the appropriate calculations. So what the student is saying is that if we have a tangent line that touches here, so it touches the curve here, right, because that's point C, right, is that that tangent line can also basically extend and go through where? Go through point D and point C, meaning it's going to intersect at these 2 points. Hope that makes sense. So maybe let's draw it visually, right? So this is the tangent line, right, that we're trying to prove, the fact that it's going to touch where? It's going to touch at C, which is also intersecting, touching and intersecting, meaning the fact that's going to touch there, and it's also going to intersect at D. So we're proving that. So what do we know? We know that the gradient at the turning point, so we know the following, right? So I'm just going to write the notes here. What's happening? Okay, cool. So what do we know, right? So first we know, let me erase this. What we know, right? So what we know, so what we know So what we know. What we know. So we know the following, right? We know the fact that the gradient, right, at a turning point, turning point is 0. So meaning that m is equals to 0, right? So a gradient at the turning point is equals to 0, right? And also a gradient of a horizontal line, is 0, which is good. Because for those two, right, to basically intersect and share the same gradient, right, is that this line needs to be a horizontal line. How do we know that something is a horizontal line? That is the second part, right? So let me just move this. I want to move this because I just want to add more notes. Okay, cut. Yes. So we know the fact that we know that, right? So then the second part, how do we know that something is a horizontal line, right? So how do you know? So this is going to be A and this is B. How do we know that a line is a horizontal line? A line is a horizontal line. We're going to go back before I write the note. Horizontal line, okay? We're going to go back and basically evaluate this. For this to share the same gradient and the gradient being 0, right, and being a horizontal line, do you see the fact that here, right, at this point, if let's say the fact that if we have a coordinate of like maybe a coordinate of 1 and 3, right? Here is that for it to be the horizontal line is that it needs to share the same y. It needs to share the same y. Why does it need to share the same y? It's because of y is here and it cuts through the y. So meaning here also it needs to be what? It needs to be maybe something and 3. Hope that makes sense. So for this line to be a proper horizontal line, right, is that it needs to share the same y-intercept. So it needs to have the same y-intercept because of this is the y coordinate here. Hope that makes sense. Because of this line cuts through this y coordinate, right? So let me just erase this so that you guys don't get confused. So if we say the fact that this is x, so we don't care about x, this is going to be y, right? Maybe y1. And also here we don't care about x, so it can be xd and y1. And this can be xc and y1. That's what we care. It needs to share the same y coordinate, right? So now let me just update this. So how do we know that something is a horizontal line, right? Both points, so we know the fact that both points need to share the same y coordinate. So meaning now, right, what are we solving? We're checking for the y coordinate. So for this question, we're checking for the y coordinate. So now put this inside a block, right? So for this question, right, we are checking whether point C and point D have the same y coordinate. Checking whether point C and D have the same y coordinate. Hope that makes sense. So now let's do that, right? So let's find point D. So finding point D, right? So we know that point D is the y. We know the fact that D is the y-intercept. So we know that D is the y-intercept, right? So I'm gonna just copy and paste the f of x, this one, right? I'm gonna copy and paste this one. Copy. Okay, go. So we know that f of x, from here, we know that f of x is equals to, let me paste this. Okay, go. So let me erase this one. Sort it out properly. So we know that f of x is equals to this one when we were done solving it, right? So do you see the fact that the one that doesn't have x, this one, which is a constant, right? That is your y-intercept. So this is your y-intercept. This is going to be your y-intercept, right? So we see that the y-intercept, so therefore point D is going to be 0 is to positive 8, right? So we see that, right? So we know the fact that the y coordinate is 8 here. Number 2, we need to find C. We need to find point C, right? So let's go up. We see that point C is the what? Is the turning point, right? So since point C is the turning point, to find the turning point, right? So we see the fact that point D is the C is the turning point. So we know that C is the turning point, is one of the turning point, one of the turning point. And to find the turning point, right? I'm going to call it TP, is that we need to do the first derivative, right, of x and equals to 0, and this is to find the x coordinate, right? This is to find the x coordinate, and this is to find the x coordinate, right? So this is to find the x coordinate. Then after finding the x coordinate, you're going to substitute it back at f of x. So let's do it, right? So we need to find the first derivative. So we know that f of x is equals to this. So I'm going to copy and paste. Let me see whether can I copy and paste it. Yes, I still have it. So we have that f of x is equals to this, right? So finding the first derivative using the rule, right, is going to be f prime of x, and this is going to be equals to negative 2 multiplied by 3, x 3 minus 1 plus 12 multiplied by 2, then it's going to be x to the power 2 minus 1, that's going to be minus 18 multiplied by 1, then it's going to be x 1 minus 1. Then since this is a constant, it's going to be 0, right? So when we clean it up, we're going to have f prime of x is equals to what? Is equals to negative 6x squared, right? Plus 24, right? X. That's going to be minus 18, right? So, but we remember the fact that we're looking for what? We're looking for when it's equated to 0. So this is going to be 0. So this is going to be 0 is equals to negative 6x squared plus 24 x minus 18. We see the fact that negative 6 can divide throughout all of them, right? So we're going to divide everything by negative 6. So this is going to be what you do to the left hand side, you do to the right hand side. So it's going to be 0 divided by negative 6 is equals to negative 6x squared divided by negative 6 plus 24x divided by negative 6 minus 18 divided by negative 6, right? So this is going to be 0, and the side is going to be x squared, right? Then it's going to be minus 4, right, x. Then it's going to be, lastly, it's going to be plus 3, right? So then we're going to factorize this. So when we factorize this, it's going to be 0 is equals to, so it's going to be x minus 1, and it's going to be x minus 3 when you factorize it, right? So after factorizing it, we're going to equate each bracket by 0. So it's going to be x minus 1 is equals to 0, or it's going to be x minus 3 is equals to 0. So x is going to be equals to what? To 1, and here x is going to be equals to positive 3, right? So go back and check where negative 1 and positive 3 are, because of it's going to be 2 of them. We see the fact that for negative 1 it's already a, so for c the x coordinate for c is what? So therefore the x coordinate for c, so therefore the x coordinate for c is equals to 3. Then remember that we're not done, we need to find the y intercept, so the y coordinate. So to find the y coordinate, so finding the y coordinate of c. So it's going to be f at x of c, right? Which is going to be the same as f of 3, right? Which now let's substitute, right? So we see the fact that when we substitute, we're going to have the following. So I'm going to just paste f of x here. Right, I'm gonna paste f of x here so we can have a reference point. So wherever we see x, we're gonna substitute by what? We're gonna substitute by 3. So that's what we're gonna do. So it's gonna be negative 2, then it's gonna be 3 all cubed plus 12. It's gonna be 3 all squared minus 18. So it's gonna be 3 plus 8. I just want to remind you guys, right? When you've done finding your 3, you do not substitute, very important, please do not substitute it here. Substitute it on the original, not on the f prime. Please don't do that mistake. You always find the y coordinate substituting to the original. Hope that makes sense, right? So punch this whole thing into the calculator. You're going to find the fact that this is going to be equals to what? This is going to be equals to positive 8. So the coordinate at c is what? It's 3 is to 8. And remember that d was what? Was 0 is to 8. So do you see the fact that since they share the same y coordinate, so that means the fact that the student's statement was true. So therefore, since C and D, right, share the same y coordinate, right? That means the student statement. So let me just look at it. That means that the student statement, that means that the student's statement was true. Statement was true. So that's how you would solve this question. So now we're going to do 9.3. It says to us point A, P, and B are joined to form a triangle PB, right? Then they tell us the fact that we need to calculate the area of that triangle. So let's join the 2 points, right? So we see the fact that we have a point A there, point P here, and point B here, right? So we need to draw the triangle. So let's do that. So we have this 2 connecting, we have this 2 connecting, then lastly this. So we need to calculate the area of that triangle, right? So we see the fact that if we draw a line going from here, so draw a line going from, it doesn't matter, going from here to here, this is going to be the height, right? So that's going to be our height, right? And this is going to be the base. So this one is going to be the base, right? So we know the fact that the area we need what? It's going to be the formula for an area. So we know that the formula for an area is what? So area is equals to half base, right? Area of a triangle. So area of a triangle is equals to half base times height, right? So now to find our base and our height is that we have the coordinate of A, we have the coordinate of B, we do not have the coordinate of P. But we know the fact that the finding the coordinate of P, let me just put this inside here, right? Finding the coordinate of P, P is what? Is the point of inflation. So finding the coordinate of P is basically finding the x coordinate first of the point of inflation, then substituting it back to the original to find the y coordinate. So let's do that, right? So let me just do this. So finding, so one, finding the coordinate P, right? What is P? P is the point of inflation, right? So how do we find the point of inflation? We know the fact that we need to find the the second derivative of x, and we need to equate it to 0. And that gives us what? This is to solve for the x coordinate. So this is to solve for the x coordinate, or to find the x coordinate. This is to find the x coordinate. Then we're going to take that x coordinate and basically substitute it back into the original to find the y coordinate. So now let's do that. We know that the second derivative, so we know that the first, we know the fact that f of x, let's do this. I'm going to just go back. We know that f of x is equals to this. Duplicate it, cut it. So we know that f of x is equals to this, right? Then we also have solved the first derivative. So let's go up, right? So we know that the second derivative is this one. The first derivative is this one. Cut, right? So we know that this is the second derivative. The first derivative, sorry. Right? So now we need to find the second derivative, right? So finding the second derivative, we're gonna apply the rule here on the first one. Hope that makes sense. So it's gonna be f double prime of x is equals to what? So it's gonna be -6 multiplied by 2. This is gonna be x2 minus 1 plus 24. Then it's going to be what? Multiplied by 1. So it's going to be x1 minus 1. Then the -18 is going to be 0, right? So now let's clean this up. The second derivative is basically equals to what? It's equals to -12x. Then this is going to be plus 24, right? But remember the fact that the rule is to equate it to 0 to solve for the x coordinate of the point of inflation. So it's going to be 0 is equals to -12x plus 24. Take the 12 to the other side, 12x to the other side. So it's going to be 12x is equals to 24. Divide both sides by by 12. So it's going to be x is equals to 24 divided by 12. So therefore x is equals to 2, right? So now with that is that we need to find the complete coordinate, right? So finding the y coordinate coordinate of P, right? So it's going to be what? It's going to be F at 2, right? So it's going to be F of 2. So now we're going to substitute wherever we see F, we're going to substitute by, wherever we see X, we're going to substitute by 2. Hope that makes sense. So now that's what we're going to do. So it's going to be what? This is going to be negative 2. Then it's going to be 2 cubed. Then plus 12 is going to be 2 all squared. Minus 18, right? It's going to be 2. Then it's going to be plus 8, right? So therefore, F at 2, right? When you punch that into the calculator, you're going to get 4. So the coordinate of P is what? It's actually 2:4. Hope that makes sense. So this point here is going to be 2:4. So we know the fact that this is going to be 2:4, right? So the nice thing is that, do you see the fact that, and I'm just going to draw it in dotted line, maybe in here, right? So it's going to be this. Okay, go dotted line. So we see the following, right? So I don't want it. Let me just, we see the following. We see the fact that this, if we draw a line going, cutting through, so let me just do this, going through like this, right? That point here, that distance here, do you see this distance here? Let me go back to solid, right? This distance here, which is going to be 4 because it shares, this distance here is going to be the same. So this from 0 to here, that's 4. So meaning H is also equals to 4 because this distance here is 4 unit because of this, because of this y coordinate. So this distance and this distance, are exactly the same thing. So we don't need to calculate H because of, we know the fact that from here going to the x-axis, right, is just the y coordinate, the positive y coordinate. Hope that makes sense. So what we need to calculate is going to be just this one, which is the base, right? So we know the fact that, so finding the area. So this is going to be finding area of triangle APB, right? So we know the fact that this is going to be equals to a half. What is our base? Remember the fact that, what is our height? Our height is just going to be H because we just know it is H. But our base, right? Our base is what? Our base is AB, right? So our base is AB. AB, right? So we know that. So what do we need? We need the following. We know that H we already calculated as being 4. We need AB. So using the distance formula. So we know the fact that A is what? Is 1:0. Then B, right? B is 4:0. So B is 4:0. So we know the fact that this is going to be x at A minus x at B all squared plus this is going to be y at A minus y at B all squared, right? So this is going to be like this, right? So now let's substitute, right? We know the fact that AB is equals to the square root. This is going to be 1 minus 4 all squared plus 0 minus 0 all squared, right? So this is going to be AB is basically equals to the square root of what? This is going to be minus 3 all squared, right? So punch that into the calculator. Therefore, AB is basically equals to 3, right? So now we know the fact that therefore the area of the triangle APB is basically equals to a half. Then the height is 4. Then the base is 3. Punch that into the calculator. We find the fact that our area, right, is equals to 6 units squared. So it's going to be units squared. So that's how you will find the area of this triangle. So now we're going to do 9.4. It says, for which values of x, right, is f concave down? So what we need to know is the fact that what is the value of x? What x are we looking for, right? So let me just write here is that the value of x, or the values of x, but here's going to be just 1 because we're dealing with concavity. So the value of x that we're looking for is going to be the x coordinate. So the x coordinate of the point of inflation. So here we're just looking at the x coordinate of it, right? So we're just looking at the x coordinate of the point of inflation. We already know that the point P, right, when we did the calculation, is 2:4, right? So we know that this point here is 2:4, meaning this point here is 2. So we're going to divide our graph in terms of those two portions, right? So let me just draw dotted lines dividing our graph, right? So going down from here to here, that's where you divide your graph, right? You divide your graph at the point of inflation, then we're going to analyze the graph, right? So we're going to analyze the solution, but before even analyzing it, is that here you're always going to say negative infinity because it's going to help you with answering, and this is going to be positive infinity, right? So now is that wherever the graph, do you see the fact that from this first section, let's name it section 1 and section 2, because the first section is from negative infinity till the point of inflation, that's section 1, and section 2 is from the point of inflation till positive infinity. So in each section, you're looking at your graph, is that if your graph is a smiley face, right, then that is concave up, which makes sense. Do you see the fact that this is up, right? And if it's a sad face, this is concave down, right? So this section here is known as up, and this one is down, which makes sense. So meaning this will be concave up, and this will be concave down. Concave down. With that said, now let's answer the question, right? So our answer is going to be what? It's going to be this section. So our answer is going to be, okay, cool. Yes, I want the big highlighter. So our answer is going to be this section. This is where concave down is, right? So that's concave down. So with that said, is that our answer is going to be from the point of inflation till positive infinity. You always write from going from left to right. So our answer is going to be x is an element, right? From where? From 2 till positive infinity. So that is your concave down, right? So that is going to be your concave down. Hope that makes sense, Anna. So now we're going to do 9.4. It says for write down the values of x for which f of x is strictly increasing, right? So dealing with strictly increasing, right, is that first we need to determine what is the value of x, right? So let's write that. So the values of x, right? So the values of x, right, for this question for strictly increasing is going to be what? It's going to be the x coordinate of the turning point, right? Always when we're dealing with increasing and decreasing, is that the values of x is always going to be the x coordinate of the turning point. So we know the fact that this is our turning point, and another one is this one, which is going to be C. Remember, let's go up. We found what C is. I think we did. Yes, it's 3 to 8. So it's going to be 3 is to 8. So this is going to be 3 is to 8, right? So now at our what? At our turning point, right? So we know the fact that this is going to be 3, right? Is that we're going to put dotted lines, right? So it's going to put dotted lines, right, going down. So we're going to put dotted lines going down so that we can separate our graph into portions, right? So that we can divide our graph. So we know the fact that, go back to solid here. right? We know the fact that this is going to be negative infinity. So this is going to be negative infinity, and this is going to be positive infinity, right? So from negative infinity till 1, this is going to be portion 1. From 1 till 3, it's going to be portion 2. Then from 3 till 4, it's going to be portion 4. Then now you're going to draw arrows on the graph, right? You always draw arrows going from left to right. Very important, following the graph going from left to right, not this direction, this direction, right? From left to right, right? So now let's go to the graph, right? Is that we're going to draw arrows going from left to right. So we see the fact that our arrows here is going to be going down following the graph, right? So it's going to be like this. Then it's going to go up here after the turning point, then down here, just like this. So the arrows that are pointing down, do you see the fact that this section is pointing down and also the section is pointing down? That is decreasing, and the arrows that are pointing up is increasing. So we see the fact that this section here and this one, it's decreasing because the arrows are going down. So this is decreasing, and this is also decreasing, and this one is increasing. Okay, let me just erase this 2 ticks, right? So what are we looking for? We're looking for when it's increasing. Strictly doesn't mean anything. Increasing, right? We're looking for when f of x is increasing. And just another thing, right? This can be also written as, they can ask you this as when f prime of x is greater than 0. This and this means the same thing, just for next time, right? So we're looking for when it's increasing. So when it's, where is it increasing? It's increasing where? It's increasing from 1 till 3. So our answer is going to be that x is an element from where? From 1 till 3. And that's how you would solve this question. Hope that makes sense. So now we're going to do what? We're going to do 9.6. It says, write down the coordinate of the turning point, very important, of h of x if f of x minus 3, right? So we know the fact that we're going to look at the turning point of first, what you call this, of h of f of x. So we have the turning point. So turning point of f of x. We have 2 of them, right? So we see the fact that the first turning point is 1 is to 0, and the other one is going to be what? It's going to be 3 is to 8, right? 3 is to 8. So now let's discuss what happens to h of x, right? We see the fact that h of x, we have f of x the way it is, but we just add what? We just add negative 3. What does this negative 3 do, right? So this negative 3, so let me just say turning point for h of x, right? So we see that h of x is equals to f of x, right, minus 3. We see the fact that here at x, nothing affects the x coordinate. Do you see that? Because x is alone here. But we see something. We see the fact that the y coordinate, right, is affected by negative 3. So this negative 3 affects the y coordinate of the turning point, right? So meaning we need to subtract by what? We need to subtract by negative 3. So meaning the turning point for h is going to be what? It's going to be basically 1 is to 0 minus 3, and the other one is going to be 3 is to 8 minus 3. So meaning the turning point is 1 is to negative 3, and the other one is going to be what? It's going to be 3 is to what? Is to 5. And that is the turning point for h of x. Hope that makes sense. So now we're going to do question 10. It says a metal block, right, without a top is constructed from a square metal sheet with sides of 20 centimeters. So let's draw that. Let's have that. So just wanna, yes. So this is the square, right? So we know the fact that this is the square, and within that is that, let me just change the color into pink blue, right? So this is the metal sheet, right? The square metal sheet. And we know the fact that what? We know the following. We know the fact that each side is 20 centimeters. So this is going to be 22, 20, and this is going to be 20 centimeters, right? It tells us the fact that by cutting, right, by cutting the square pieces of equal size from the corner of the sheet and then folding them up as sides. So what's happening is the following. So I'm just going to draw dotted lines. So is that we're going to basically cut the four corners equal sides. So let's do this so that it makes sense. So let me just do this because I want to keep the square the same size. Is that we know the fact that we're going to create like dotted lines here, right? Dotted lines here and dotted lines here, right? So basically the square that we're focusing on is this one. So let me just back to solid. So the square that they're talking about is the squares, right? And they all equal sides. So this is the square, right? This is the square, this is the square, right? And this is the square. And they tell us the fact that all the squares are equal, right? Since they're equal, we're going to let that square be x. So this is going to be x, right? And this is going to be x. So all of them is going to be x here. And this is going to be x, 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 right? Meaning now our length here, our updated length is going to be what? It's going to be this 20. Remember this 20 is this whole blue one minus this 2x. So here it's going to be what? It's going to be 20 minus 2x. And we know the fact that this, and this are all going to be the same because of the corners that we cut are all the same. Hope that makes sense, right? So this is going to be also 20 minus 2x. This is going to be 20 minus 2x. And this is going to be 20 minus 2x. Hope that makes sense, right? So they tell us that, and they tell us the fact that we're going to fold it. You see where the black dotted lines are, right? We're going to fold it up, meaning this is going to be the base, right? And when we fold it up, is that this is going to be the height. So this is how the box is going to look. So the box is going to look like this. So the updated box, the one that's going to be with the base at the top. So it's going to be this, like this. So let me just go back, erase that, right? So it's going to be like this, right? So it's going to be like this. Okay, let me just, I just want it like this. So it's going to be here, like this, right? Then the sides, do you see this is the side? So this is the side. So this is the side. This is the height, which is x, and this is going to be the side. So that's what I'm drawing, right? So this is going to be like this. So this is the box, right, with an open top. So we know the fact that now, we know the fact that this is going to be 20 minus 2x, and here's going to be x, and here's going to be 20 minus 2x. Hope that makes sense, right? So that's how it is, right? So this is the updated box when folded. Then they say calculate the diameter of the box, right, with the largest volume, right, that can be constructed in this manner. So the largest volume is that we're going to find the first derivative of the volume. So largest volume. So largest volume means means the fact that we need to find the first derivative, right, and equate it to 0. Then now, since we understand what is the largest volume, is the finding the first derivative equated to 0. The question says calculate the diameters of the box with the largest volume. So the diameters is this, it's this, and it's this. So we're looking for the height, we're looking for the length, and we're looking for the width. That's what we're calculating, right? And we see to find them is that we just need to solve for x and substitute to find those length, right? Hope that makes sense. So with that, let's put this information inside a box, knowing the fact that what is the largest. So now let's calculate what? Let's calculate our volume, right? So we know that our volume is equals to what? Is equals to the length times width times height, right? So going back to the diagram, this is the length, this is the width, and this is the height. So let's substitute, right? So we see the fact that our volume is going to be basically equals to 20 minus 2x. Then it's going to be 20 minus 2x. Then this is going to be x. So now we're going to expand this. So it's going to be what? It's going to be 400, right? Minus 80x plus 4x squared, right? Then this is going to be x. Then we're going to distribute the x, right? So it's going to be, volume is now going to be equals to 400x minus 80x squared. Then this is going to be what? Plus 4x cubed. Rearrange it, write it by starting by our 4x cubed. So it's going to be volume is equals to 4x cubed, right, minus 80x squared plus 400x. But remember the fact that finding the largest means this, right, means this. So let's do that. So we know the fact that we need to find the f prime when it's equals to 0. So the first derivative, we're going to apply the rule. So it's going to be 4 multiplied by 3. Then it's going to be x3 minus 1 minus 80, right, multiplied by 2. x2 minus 1. That's going to be plus 400 multiplied by 1. x1 minus 1, right? So let's clean this up. It's going to be the first derivative. So the first derivative is going to be equals to what? It's going to be equals to 12x squared, right? Then it's going to be minus 160x. Then it's going to be plus 400, right? So we know the fact that this is equals to 0, right? From here, so this is going to be 0 is equals to 12x squared, right, minus 160x plus 400. Then we see the fact that 4 can go through all of them. So we're going to divide everything by 4. So it's going to be 0 divided by 4 is equals to 12x squared divided by 4 minus 160x divided by 4 plus 400 divided by 4. This is going to be 0 is equals to 3x squared. Then this is going to be minus what? Minus 30. Sorry, not 30. Minus 40x. And here's going to be plus 100. Right? So now we're doing that. You can use the quadratic formula, right? But when you factorize this, right, you're going to get the fact that 0 is equals to what? Is equals to 3x minus 10. Then the other bracket is going to be x minus 10, right? So therefore, equating each bracket by 0. So this is going to be 3x minus 10 is equals to 0. Or x minus 10 is equals to 0. So take the 10 to the other side. It's going to be 3x is equals to 10, right? Is equals to 10. Then x is going to be equals to 10 divided by 3. This side is going to be x is equals to positive 10. But if we go back, we see that our volume formula, right, it's what is a cubic function. What do we know about a cubic function? Is that it has two turning points. It has a maximum and minimum, right? So our question says what? It's very important. They stated the fact that we need to find the largest. Largest means the fact that we're looking for the maximum, right? Largest means the fact that we're looking for the maximum. So looking for the maximum, we need to basically draw the cubic function. So finding the maximum, right? Since the volume is a cubic function. Right? So to do that, we need A. So we know the fact that A is equals to, let's go back to the one that I underlined, is equals to 4. Right? So it's equals to 4. Since A is equals to 4, we know the fact that that's greater than 0, meaning it's positive, meaning our function looks like this. It goes up, then down, and up. Just like that, right? This being the maximum, which is what we want, and this being the minimum. So the smallest value goes here because we put our numerator from left to right. So the smallest one is going to be here. So 10 over 3 is here and 10 is here, right? So therefore for the largest volume, we see the fact that x is equals to 10 over 3. But remember the fact that they said the fact that we need to calculate what? We need to calculate the diameters. Diameter is this one, is this one, and is this one. So we need to calculate the diameter. So now we're going to say calculating the diameter. So we know the fact that calculating the diameters. So calculating the diameter. So we're going to be calculating our diameters. So calculating the diameters, right? Diameters, right? So we know the fact that we're going to be looking for what? Height. So we're going to be looking for height. And we know that height is equals to x, which is equals to 10 over 3. Then we're going to be looking for length. Our length, we know the fact that is 20 minus 2x, which is the same as 20 minus 2. Then it's going to be 10 over 3, right? Which is going to equals to 40 divided by 3, right? So centimeters. So it's in centimeters. Then also our width is going to be the same thing as 20 minus 2x, which is going to be equals to 40 divided by 3 centimeters. Right? So that's how you would do this question. So now we're going to do probability. So with probability, right, it's question 11. So we're going to do question 11. It says a 6-sided dice is rolled and a number of dots landing face up is noticed, right? We know the fact that a dice has 6 sides, right? Then they say the fact that consider the following event, right? So we know the fact that the sample size, right? So the sample size, which is S, right, is going to be the following, like the total sample. So from this, if we're going to be considering events, so we know the fact that the sample size, right, the total sample, right, which is we're going to say is basically equals to all the sides. So we know the fact that all the sides is 1. We have a side with 1 dot, a side with 2 dots, 3, 4, 5, and 6. So that is the total, right? The total outcomes in terms of when rolling a dice, right? Then the first one, it says we need to consider the following event. So they tell us that event 1, right, event A, is the number observed is 2 at most. So what is at most? This part at most, right? It's starting from at most, meaning the fact that we ending at 2. Hope that makes sense, right? So at most means the fact that is the number before it, then we end at that number, which is in our case is 2, right? So at most 2, so event 1, event A, right, which is at most A, at most 2. So okay, cool, doesn't want to erase. So at most 2 is the number before this number, which is going to be 1 and 2. So the sample is going to be 1 and 2. Maybe I should just explain at most again so that it makes sense. So let's say the fact that they said to you at most 4, right? We see the fact that 4 is this one, so it's going to be 1, 2, 3, 4. We end at that number that they say after at most. So at most 4 will be that. At most 5, we're going to end at 5, so it's going to be 1, 2, 3, 4, 5. At most 6, meaning it's everything. So at most 2, it's going to be this and this. Hope that makes sense. What's at most, right? Then we're gonna have event B. So event B says the fact that the number, so the number, right, the number that landed face up is even number. So it's all the numbers. So event B is all the even numbers. So event B is even numbers. So it's even numbers. So it's going to be what? So it's going to be 2, 4, and 6. Hope that makes sense, right? Then event C, right? It says the number facing 6, so it's just 6. So event C, right? It's going to be just facing. So facing 6. So it's just going to be 6. Hope that makes sense, right? So with that said, let's go answer the questions. So now we're going to do question 11.1.1. It says what? It says determine separately the probability of event A and event B, right? So we need to find the probability of event A and probability of event B. So we know the fact that the probability of event A is going to be what? It's going to be A, right, divided by what? Divided by the sample. So we know the fact that A, how many are there is 1, 2. So it's going to be 2 divided by the sample, which is the total, 1, 2, 3, 4, 5, 6. So it's going to be divided by 6. So therefore 2 divided by what? 2 divided by 6 is going to give me 1/3, right? Then probability B is going to be B divided by the sample. So it's always the event, right, divided by the total sample, which is our total sample is S, right? So it's going to be what? B is how many are there? It's 3. So it's 3 divided by 6. So that's going to give me a half. So now we're going to do 11.1.2. It says use the probability A to determine the probability of A prime. So the formula, if you're looking for the A prime, is going to be like this. So it's going to be probability of A prime is basically equals to 1 minus the probability of A. So we already know what's the probability of A. So this is going to be 1 minus, what's the probability of A? 1/3, right? Punch that into the calculator. You find that the probability of A prime is basically equals to 2/3. So now we're going to do 11.1.3. It says other events mutually exclusive, give reasons. What is mutually exclusive, right? So mutually exclusive. So mutually exclusive means that, right? Means that they is no intersection. Enter. So meaning now for them to be mutually exclusive is that all 3 of our events, right, they need to have what? They shouldn't have any number that they share in common. If they do, then this is not mutually exclusive. If they don't, then there is mutually exclusive. Hope that makes sense, right? So we're looking for whether there is a common number within all 3 events. If there is, then that means the fact that that is not mutually exclusive. If there isn't, then it's mutually exclusive. Hope that makes sense. So paste, let's take all our 3 events, right? So these are our 3 events, right? We see the fact that within our 3 events, let me just within our 3 events, this and this one have a common number, which that is like enough evidence to say the fact that this is not mutually exclusive. And also this and this have a common number. So now our answer is going to be what? It's going to be no, the events are not mutually exclusive. And remember that we need to give reasons, right? We need to give a reason. Mutually exclusive, right? Mutually exclusive because event A and B share number 2, right? Because event, because let's do this, right? Because of it's 2 of them, because event A and B share the outcome 2. So share the outcome 2, and event B and C share the outcome 6. Share the outcome 6. Hope that makes sense, Anna. So now we're going to do 11.1.4. It says calculate the probability of A or C, sorry. So now it's using the addition rule. So it says that the probability of A or C is equals to the probability of A plus the probability of C minus the probability of the intersection. So A and B, right? So A and C, sorry. So this is going to be A and C, right? So now I'm going to go up and I'm going to take all the events so that we can find the probability. So duplicate, cut, right? So I'm just going to put it, I'm just going to put it here. Just going to put it here, right? So we know that the probability of A, right? So we know that the probability of A, we already found it. So the probability of A, remember the fact that it's what? It's 1/3. So it's equals to 1/3. Then now we need the probability of C. We didn't find the probability of C, but we see the fact that it's going to be 1. So the probability of C is going to be C divided by S. And this is going to be 1 because it's only one value divided by 6 because that's the total sample. Remember, so that's the total sample, which is this one, right? Then now we need the probability of A and C. A and C means a common number between event A and event C, right? So we see the fact that this and this, there isn't any common number. So the probability of A and C, since there isn't any common number, right, is going to be equals to 0. Right? So now substituting, we know that the probability, so the probability of A or C is equals to the probability of what? So we know the fact that the probability of A, right, the probability of A is 1/3. So it's going to be 1/3 plus 1/6 minus 0, right? Then what we're going to do is that we're going to punch that into the calculator. Right? So when you punch that into the calculator, you find the fact that the probability of A or C is equals to what? It's basically equals to 1/2. And that's how you would find this answer. So now we're going to do 11.1.5. It says B and C independent events, right? Then give reasons, right? Give reason to our answer. So to find independence is that we need to use this formula, right? So this is the formula where we calculate whether an event is independent or not, right? So So calculating independence. So I'm going to say calculating independence. So that we use this formula. Events. It's going to be the probability of what? In our case, it's going to be the probability of B and C, right? Is equals to the probability of B. So it's going to be the probability of B multiplied by the probability of C. So we're trying to prove that the left hand side is equals to the right hand side, meaning we need to calculate them separately. And if we get them to be equals to each other, then the events are independent. If they're not, then they are not independent. So now let's find the probability. First, so let's find the probability of B and C, right? So we need to go back, right? Let's look at the event. Remember the fact that it's B and C. We see that B and C share a common 6, meaning they have one common number, meaning it's going to be the probability of A and B is going to be this one number, right, divided by the total sample. So it's going to be what? It's going to be that one number, which is 6 divided by 6. 1 divided by 6. Hope that makes sense, right? Because they share only one number, which is the red one, right? Hope that makes sense. Then we see the fact that now we need to find the probability of what? Of B multiplied by the probability of C, right? We already know that the probability of B, if we go up, right? If we go up, we already calculated that the probability of B is 1 over 2. So we know the fact that's going to be 1 over 2 multiplied by the probability of C. When we were calculating here, we know that the probability of C is 1 over 6. So it's going to be 1 over 6, right? So when you say 1 over 2 multiplied by 1 over 6, we get the fact that that is going to be 1 over 12. Then we see the fact that, therefore, we see that the probability of B and C is not equals to the probability of B, right, multiplied by the probability of C. Because you see the fact that this one is 1 over 6 and this one is 1 over 12, and that's not equals to each other, because we know the fact that this is 1 over 6 and 1 over 6 is not equals to 1 over 12. Hope that makes sense, right? So therefore event B and C are not independent. So they are not independent. Hope that makes sense. So now we're going to do 11.2. It says the following: the probability of getting the first answer in a quiz correct is 0.6, right? So then they tell us the fact that if the first answer is correct, right, then the probability of getting the next one is 0.3. Do you see the fact that in this situation, the second one depends on this one? If something depends on another one, that means the fact that we're dealing with tree diagram, and they're going to tell us at the end. Then it continues the fact that, however, if the first answer is incorrect, right, then the probability of getting the next one is 0.4. Then they say with a tree diagram, so determine the probability of getting the second one correct. So now let's draw the tree diagram, right? So correct, so code, so let C be correct, right? And let W be wrong, not correct. So it's going to be not correct, right? So it's going to be not correct, which is going to be the same as the wrong one, right? So we start by this. So we start here. Let me just see whether do I have space. Yes. So we're going to start here, right? So when we start here, we see the fact that we're going to either have correct, right, or we're going to have incorrect, right? So that's the first branch, right? So we see the fact that they tell us the fact that, and I'm just going to use a highlighter, right? They tell us that the probability, so the probability of getting the first answer in the quiz correct is 0.6. So the first answer is the first branch, right? It's going to be the first branch. This is going to be what? This is going to be 0.6. 0.6. So, but since we're dealing with probability and both of them, when you add them together, it needs to be equals to 1. So when you say 1 minus 0.6, this is going to be what? This is going to be 0.4, right? So we know the fact that this is when it's correct and this is when it's incorrect, which is going to be W. Hope that makes sense, right? Then they continue and say the following, right? The first answer is correct, right? Then they tell us the fact that the probability of getting the next, so meaning the second branch, correct is 0.7. So meaning now this is going to be the second branch. So we know the fact that it needs to be first correct, which is going to be the first branch, right? So it needs to be first correct. Then the probability of getting the next one correct, meaning it's going to be the second branch, right? So now let's do the second branch. So the second branch is going to be like this, right? So meaning even here, it needs to have the second branch like this, right? So we know the fact that we need correct and wrong, which is incorrect, and it's going to be correct and wrong, right? So they tell us the fact that the probability of getting the first one correct and again correct is going to be what? It's going to be 0.7. So when you say 1 minus 0.7, this is going to be 0.3. Because when you add those two branches together, you need to get what? You need to get 1. Hope that makes sense, right? Now they tell us, they continue, they said, however, if the first, right, answer is incorrect, so if the first answer is incorrect, so we're dealing with this branch. So if the first answer is incorrect, meaning we're going to talk about the second diagram, right, the second branch. So they say the fact that however, if the first one is incorrect, right, and the probability of getting the next one correct is 0.4. So this one is 0.4 because the first one needs to be incorrect, then correct, which is 0.4 is here. So this is going to be 0.4. So when you say 1 minus 0.4, this is going to be 0.6, right? Hope that makes sense, right? So now let's see what they want. They say with an 8-over diagram, which is we have our tree diagram, determine the probability of getting the second one correct. So we're looking for at the second branch, we're looking for when it's correct. So we're looking for when it's correct at the second branch, and we need to calculate the probability. So the probability is that you need to basically see how you get there. So it's either you get it correct, right? And when you get it correct, you get it correct again. Then you land at the C. Or it's either you get it incorrect and you get it correct again, and you're gonna end at that C. Then what we're gonna do is that we're gonna multiply this 2 plus you're gonna multiply this 2, right? So the probability, so now let's answer it. So it's gonna be the probability of getting, so the probability of the second being correct, it's equals to what? It's equals to 0.6 multiplied by 0.7. So the ones on the same, this one, so it's going to be this multiplied by this, plus another option is this multiplied by this. So it's going to be plus 0.4 multiplied by 0.4, right? So now having that, you're going to punch that into the calculator, right? So when you punch that into the calculator, you're going to have your answer as being what? As being 0.58. So 58%, right, is you getting it correct at the second try.